Okay, I think we can start. Thank you again to be here. As I mentioned, today is really a very busy day with a full of speech and event agenda, also due to the Pellizzi Prize. I'm happy you are here, still in a certain number. This is very important also for the young PhD students, the winner, that will be happy to have your attendance when they will make the presentation of a PhD work and research. So thanks again to be here. So we can now start it. As usual, as you know, in our agenda, we have a third sections related to specialized mechanization. So we have in the previous years speak about several types of specialized mechanization. We speak about specialized mechanization for horticulture, for vineyards, for orchard, for other type of specific crop. And today we have decided for a topic that is really a complex topic, that is the grassland management. I don't want to go too much deep about this, but there are a lot of aspects to be considered when we wanted to find the best solutions in terms of management of grassland. Seems easy because when we speak about grass and the use of grass productions for feeding animals is something simple and easy. There is a historical way to do that for a long time, but it's really a complex aspect if you want to do that in the best way as possible. So, but I don't want to go too much far forward because also the time is limited. So I really thanks all the speakers. The third one is coming from Kuhn company, but this will be after the coffee break, so it's not a problem. They are not yet here. But I would like to start with the introductions of Dr. Turner from the Bavaria State Research Center for Agriculture that has tried to make, this was my suggestion, I know it was not so easy, a kind of introduction into permanent grassland management in terms also what is going on around the world in terms of surface of a grassland. So please, Stefan, the floor is yours.
So thank you, Professor Bolzari, for introducing myself. It's a great honor for me to be invited here to talk to you today about the permanent grassland management worldwide. And as Professor Bolzari already said, it was quite a struggle to get this presentation done. So what have I to show you? So first of all, grassland worldwide and development of grassland, and then also I would like to show the managing practices on the one hand on grazing and on the other hand on harvesting grassland. And I would like to give some perspectives for the future grassland management. So when we start with grassland worldwide, there are always these maps from the FAO, which I also took. And here you see in this yellow and orange colors, the grassland that is situated worldwide, definitely. And to make it easier for you to know where it is, the biggest portion of grassland, more than 1 billion hectares, is situated in Asia, and then follows Africa with 868 million hectares of grassland. And then we have 3 areas with the same share: South America with 380 million hectares, North America with 360 million hectares, and Oceania with 340 million hectares. And all together in this continents, we see that there is more grassland than cropland. So Europe is the one with the lowest share of grassland. Here we only have 170 million hectares. And different to the other continents, we have more cropland than grassland. So this is special in Europe. So we've done sort of a better job in plowing the grassland, you could say. So how was the development of the grassland during the last 2 decades, since 2001? So Generally, agricultural land area is shrinking. We have at the moment nearly 37% of agricultural land area on our planet, and it was shrinking during the last 2 decades by nearly 2%. And when we look at cropland, we see that was the other way around. So we gained cropland worldwide. We are up to 1/3 of the agriculturally used area in the world is a cropland. And here, especially in Africa and also South America, we saw an area expansion due to deforestation. So it grew during the last 2 decades with more than 5%. And what happened to grassland? Well, it declined. It was shrinking during the last 2 decades. At the moment, we are only at 67% of grassland. I've always got in my mind the number of 70% of the land area that is grassland. So we are already going down by minus 3.5% during the last 2 decades. And of course, then there is also an area on the cropland that we sort of manage grassland-like. So temporary meadows and pastures, and that area is also quite high. It's 8.7% of the cropland. But again, that was shrinking during the last 2 decades by minus 3%. And here, mainly in Northern America, Europe, and also Asia. So we drive out these temporary meadows and pastures of the cropland. So if we calculate it together, the grassland area and also this temporary grassland-like area, we come up to 3/4 of the area of the agriculturally used land in the world, which is grassland-like. So it's actually the biggest crop that we use on our planet. So what is grassland? I think it plays a real key role when we compare it to cropland and also to forest. So first of all, we already saw it's the largest proportion of land use that we do. Second, it is actually the largest carbon storage in the soil, even before the forest. So grassland is the main carbon storage on our planet. So it is really a key role here. It also is responsible for the biodiversity. So we have the highest biodiversity on grassland, also even before the forest. So grassland is really crucial here to keep up biodiversity in our world. And it provides multiple ecosystem services, like just think about soil erosion. So we have a permanent cover all year round, or think about water retention. So grassland is really a big player, and it's a key role of our land use worldwide, I would say. So how do we manage the grassland today? Well, it's mainly situated on marginal land. That's because everything that can be used as cropland is already, I think, used as cropland. And everywhere where there is some limitations like inclination or soil parameters, a lot of stones, or the water availability in both ways. So it's either too dry or it's too wet. These are limits that we are not using it for cropping. So we are on marginal land, and that gives us a very high heterogeneity even in smaller plots. So this is really the area that we should manage. So there is a lot of difference in grassland, much more difference than we have on cropland, definitely. So how can we use it? So we can use it either as natural grassland, semi-natural grassland, or intensively managed grassland. Natural grassland would mean that we are not doing a lot about it. So we are not reseeding, we are not fertilizing. We just use it for grazing, so the animals go out and eat what's growing. So we don't care about it. Semi-natural, that's a little bit more intensive. So there we already care about our swards. We may be bringing in seeds, we may be doing some fertilization. But it's still also used mainly for grazing. And then, of course, we come to the intensively managed grassland. And there we really make a big fuss about it. So we do reseeding, we do fertilizing, we do irrigation. And it can also be used for grazing, like for dairy cows, it's often done. And there we also come to the production of silage or hay as feedstocks for times when there is no grass growth. And that's on most of the sites in the world that we have some times without growth, and we have to use conservated feed for that time span to feed our stock. And therefore we mow this grassland in order to produce grass-based feed stuff. And of course, then we have these temporary meadows and pastures on cropland, and they are also intensively managed, normally mainly mowed in order to produce some feed stuff for the cattle. So when we come to grazing, first of all, we have to say it's essential for grassland preservation. So we have a struggle on a lot of parts in the world that we look for farmers that graze the area to prevent it from being grown with trees. So, and if grazing is well managed, it can really promote soil quality, also biodiversity, and provide further ecosystem services in combination like with the nitrogen cycle, or also the soil organic carbon stock, or the soil water content. And grazing is the best way to keep the animals. It's good for animal welfare and health. It's the natural behavior in a herd of the animal that they graze. And we actually found in a nice evaluation that if the heifers have been reared on an alpine farm grazing, they actually have better health, and they end up with a higher production lifespan as a dairy cow. So there is really also something that's going together here. So what are the grazing principles? Well, we have continuous grazing and rotational grazing. These are the two main principles, meaning that with continuous grazing, the livestock is always on the grazing site. So we rather manage the number of cattle that we bring up and take off in order to meet the growth. And then with rotational grazing, where also mob grazing or cell grazing, that's just some newer words are included, the livestock is shifted regularly over the grazing sites, and these paddocks which we use for grazing can even be subdivided for certain amount. So, and of course, besides that, there is some seasonal grazing. I've already mentioned that there are sometimes times without grass grows, but it also includes lay farming or pre-seasonal grazing and post-seasonal grazing or conservation grazing. So the livestock is also not permanent on the grazing sites. And what we can also do is mixed species grazing. So we use horses, cattle, sheep, and so on. So they use the grass sward in a different way, and that brings up more heterogeneity and more biodiversity, actually. What about data in grazing? So most of it is manual recording up to date. So to measure the growth, the regrowth, and also the residuals after grazing, we have to go out there and do it by hand. So there's not that much automated yet. We use this plate meter, but you still have to walk over the area. The management itself, it's also most of the times without any digital assistance, and also no decision support systems are in place here. There are only locally solutions that are used by the farmers, but most of it is done really manual. So farm management information systems are totally missing when it comes to grazing. Worldwide, I would say. A few systems are already in use. So we have some livestock tracking systems and geofencing systems like from Norway or Austria, but that's what's on the market somewhere, but not even in use in Central Europe, for example. And there is hardly any further data like on animal behavior or on estrus detection like the farmers are used to in the barn. So they have a lot of sensors in the barn, but they cannot use it on the pasture at the moment. So it's really, when they go out on the pasture, it's more or less a black box for the farmer, and he doesn't know, what the cattle are eating and so on. And I think what's changing the game is the virtual fencing systems that come in the market right now. So we have 4 companies, NoFence, eShepherd, Vance, and Halter, that are producing the systems and have them on the market already. So there are more than 250,000 systems already on the cattle in practical farming, and most of them are suited for cattle, but no offense also for sheep and goats, they say. So I think this is really a game changer when it comes to grazing, and we will find a lot of new ways of grazing in future, to my opinion. What are constraints in grazing? Well, of course, first of all, you need the infrastructure. So you need a fence, you need water troughs, you need driveways for your cattle. So that's an invest before you start. And then, of course, you have the seasonal differences in growth and also quality of your sward. So that means when you feed a dairy cow, your daily milk yield will change with the grass growth and the grass quality, and even your milk bulk contents will change. So, and the feed intake of the animal is unknown to the farmer. So he doesn't know what the dairy cow was eating out there on the grassland. So he doesn't know, do I have to supplement the cow in the barn? Is concentrate enough, or do I need even some more feed stuff? So that's a really big thing where the farmer has to have good skills in order to get it right. And then also we have a lot of automatic milking systems there out in the dairy farms that have been used, and still it is quite challenging, this combination of grazing and automatic milking systems. We have other problems like with large predators. That's a big topic at the moment in Europe, that we have the wolf pack, and that threatens our grazing animals. And of course, there is overgrazing all around the world on certain spots, and this leads to a loss of grassland, to a loss of biodiversity, and also to a higher greenhouse gas emission, like the situation we have in Mongolia, where they overgraze their land, and then the permafrost starts thawing, and methane is going out into the atmosphere. So this was about grazing. Next, I would like to show some things about harvesting. The first thing on grassland is that we have not only one harvest, so we have several harvests through a year. So 1, 2, 3, and 4th cut, for example. And we can use it in a different way. So we either use it as a fresh biomass, directly fed the animals, but most of the time we conserve it as a silage or a hay, and all in between. So there are different things between silage and hay you actually can make out of grass. And it can also be combined, harvesting grassland sites and graze them at certain times. So it's a big, differentiated use of this grassland. So, and I've just want to show here one example of a farmer. So in the first cut, he says, well, I need this grass silage for the winter. So I bring it into my bunker silage. So I do the wildlife rescue measures with a drone and a thermal camera. Then I come with my disc mower for mowing. Maybe I have to ted depending on the weather conditions, but then there is definitely the rotary rake to swath it. And I use the forage harvester for harvesting. So that would be the first cut. Then in the second cut, he thinks, well, I need some hay for my heifers. So he makes bales, again, mowing and then tedding. There he has to do the tedding several times. And he uses the merger for swathing already because he knows that there are big losses with the rotary rake. And then the baler comes again with some big losses here, but there is no alternative at the moment. And then in the third cut, he's happy to be in a region where there is a hot air drying plant. He produces crops as more a concentrate feed also. And there comes the contractor in with a mowing and swathing device that is doing it together. And then he harvests with a loader wagon. And in the fourth cut, he says, well, I will do post-grazing. So I send out my animals to eat what's grown in the autumn. So, but how is he managing this grassland now? So he doesn't know what the yield is actually in each cut, and the final goal is to know what is the yearly yield on my grassland. So he has to sum up all these cuts. So in the first cut, he has the forage harvester, there is yield determination available for it, so that's not a problem. In the second cut, so there it starts already the problem, so he can weigh each bales. There are some techniques on the market where you get the bales weighed directly while you make them, but it's not very widespread. In the third cut, it's again not a problem because at the drying plant, there's a cart scale, so he gets the weight of what he was producing. And in the fourth cut, again, no technique, so he has to run around with his plate meter maybe in order to get some numbers. And when it comes to site-specific management, it's only in the first cut where he is able to produce actually a site-specific yield map. So with all the other things, he is only getting a big number if it's going well for one plot. So you see there is all sorts of usage on grassland, and we always need this yearly yield. So that's really our goal in dry matter yield, so not fresh mass yield. And we've tested some of the forage harvesters. The 4 companies named here, John Deere, Claas, CNH, and also Krone, with their different models of near-infrared spectrometer and different software versions on 10 Bavarian farms, as you see on the left side on the slide. And what we found is that this technique, the yield determination on self-propelled forage harvesters, is already very well developed. So we've compared here wagon loads that were calculated by the forage harvester and that were calculated from our reference data, and you can see that it's really nearly matching. So I'm very happy with that figure. So it's a very good way to determine your yield on the grassland. And we've also compared it on a plot scale, and we found this concordance correlation coefficients of 0.78, which is quite good. So here you can really say that we are on track. But what about satellite? Well, of course, I forgot the self-propelled forage harvesters. They also do the ingredients, which is a great thing. So we can also get some information about, for example, our crude protein content of what we harvested. And as you see here, so these are the different ingredients I've put in this graph. There are some that work quite well already. There are some that need some improvement, or well, maybe it's always not so easy with the near-infrared spectrometers on a forage harvester really to predict what's in there, because you only see a part of the material flow and so on. So what about the satellite data? Can there also be a solution? So we've bought a set of data for 2 farms from the company Vista with their model and their growth model, and that's the result. And it wasn't really good, I would say, at the moment. So they made their models on peatland, actually, in northern Germany. So obviously the peatland in northern Germany is not the same that the grassland in southern Germany. And here we only found a concordance correlation coefficient of 0.5, which is nothing you would deal with. So there is still improvement needed, and I'm pretty much sure that we need both of it, so the forage harvest and also the satellite data, in order to get to our yearly yield. So we harvest with different process chains, as I already showed. We harvest many plots always together on a single farm, and I already mentioned that there is a big heterogeneity on these grassland sites, and this is one example for it. So here you see a dairy farm in Germany where we measured the yield in 1 year. So he does 6 cuts, and the first 3 column parts are 3 meadows, and then there is coming 2 cropland areas with grass clover mixture. And when you look at the blue bars, you see that in the first cut, the meadow 1 was the one with the highest yield, and then followed meadow 2 and meadow 3, so it goes down. But then, surprisingly, in the second cut, you see that meadow 2 is the one with the highest yield. So there's even a shift in the different cuts, even that it was the same management on all this grassland. So we have differences within the year, between the plots, between the years, and that it's also between the years. You can see on this graph, which we done earlier on 5 Bavarian state farms, and there it's the same situation. So I always say I guarantee each farmer the factor 2.5 on his grassland. So when he comes from his lowest yielding grassland and takes it times 2.5, he comes to his highest yielding grassland. And that's a really large span, I would say. And we are managing at the moment all these grasslands the same way. So we don't care about these differences, actually. And of course, the farmer itself, they hardly know about the yield of the grassland. So this yield determination stuff is not yet really in charge on a lot of farms. And even when it comes to site-specific stuff, well, there is no knowledge at all on the farms, I would say. And well, of course, why is it also that way? Because the technique we use on grassland, that was not designed for grassland. So it was designed for silage maize. That's the forage harvester that was made for silage maize. Or it was made for crop farming. So we drive with big trucks over our grassland with high axle loads. And there are some studies out that say that we lose, with only one driving over grass with 4 tons of axle load, more than 10% of our yield. There are also numbers that say it's 20%. So with only one time going over your sward. And we do this several times a year. So yeah, I think we really have a lot of optimization to do here. So what about the perspectives for future grassland management? So I think we need yield determination at least on a plot level for each farmer. And ideally, we would have yield maps on a site-specific management. I really think that's worth doing. And we have to combine, therefore, the forage harvester. So if we can get in the forage harvester for harvest, that's the better option. If we don't have the forage harvester, we should be able to use satellite information in order to get to our yearly yield. So, but also for grazing situations, as you saw, we can do this mixed use. We need some better yield recording methods that are more automated. I don't know if the satellite can help us there, but yeah, there's need to do work. So I think the agricultural machinery industry must develop and offer really customized solutions for grassland, so that are made with the thinking of grassland. So where do we have them already? So there are, of course, some examples. It's like this nice thing which we can do, reseeding or seeding with variable seed rates, even with a sensor in front of our tractor, or it's just came into the market, the spot spraying for dockweed. So that's also a quite nice technique. Solutions, I already mentioned the forage harvesters. Then we have some things new on the merger side for reducing losses. We also have on the loader wagons some good ideas. For example, automatic speed regulation for picking up the material. Then we have these nice barn high drying systems with dehumidifiers that really conserve our quality on grassland. So there are things that are going well, I would say, but there are also things which I can't believe that they're still not in place. And when we start with the farm management information systems, you have to really say, well, we're not doing a good job there at the moment. Most of the time, the farmer has to note down his yield of the plot on the harvester, or he might get, if he's got a good contractor, a sheet of paper with a nice colorful picture, but that's it. So when he's entering it into his farm management system, he will do this manually again. So there are already solutions that can automate this, but we found with all these 4 companies we work together, it's not working. So the farmer would never be able to get this data from his contractor to his farm management system in a way he wants it, and he can use it actually. Yes. So and that's incredible to me, that we offer systems to the farmer that are not working, and especially not working for grassland. And of course, yield is the one thing, but then we come to slurry application. We could also use these farm management systems there, and then we've got this big gap, the silage stack, and also the slurry storage, where we don't have any data. So we have the ones that care about the animals inside the barn, and we have the ones that care about the grassland outside, but we don't have these people that bring it together. So that's also a big lack, and the silage stack is definitely one part on a farm where we have huge losses. So they start at 10%, and if it's not well managed, they go up to 20%, even more than a third. So especially in those biogas plants we have in Europe, they lose most of the time more than 20% of the material they brought into the silage stack, and they can't use for producing energy. Yeah, so and some simple things. We've talked already to the industry. So the farmer cannot summarize his yearly yield at the moment from the different cuts. There is no software solution for farmers and even for scientists. So they have to do it on their own to sum up the first, the second, and the third cut to get to the yearly yield. It's not existing. It's an easy task, but not existing yet. So, and again, problem, Markus Demel told me that it was the same when they invented the yield measurement on combine harvesters. They calculate with fresh mass yield. So what should we do with fresh mass yield on grassland? I mean, we are at a dry matter content of 35% or so when we make silage. So what is that about fresh mass yield? So we need the dry matter, of course. That's the only number we need here, but the companies still calculate with fresh mass yield, so the farmer can really get screwed with that. Site-specific management, to my opinion, is also not yet really understood, so we actually do not have, also from the scientific side, no real recommendation for the farmer. Which map should he use to do what? So is it a map of the first cut? Is it really the map of the yearly yield that he has to use for making decisions? And what is actually a good decision for the certain different harvesting spots? So we don't actually know what to say to the farmer. What should he do with the lower harvesting areas and with the higher harvesting areas? How should he differentiate the management? And of course, we also don't know what happens later on when we do differentiated management, so site-specific management on these different yielding parts of our grassland. What will it do to our yield, really? What will it do to our quality of the grass we harvest there? So it's actually not known, to my opinion. So final slide. I think we desperately need more solutions for our biggest crop in the world, which is grassland, and no one's really caring about it, in order to use and also enhance its potential also in the future. Thank you very much.
Thank you very much, Stefan, for your, I think, very useful introduction and nice speech. Now I speak from here because Marco have to just put in the PC the next presentations, which title just explain the author's feeling. So the author are my friends, Professor Mazzetto and Professor Grunauer, that is also a Club of Bologna full member from University of Bolzano. And the title is The Frontiers of Forage Mechanization at the Service of Efficient Livestock System in climate smart agriculture strategies. So really a lot of aspects that are considered in this speech. I know Fabrizio from a long time. I know that normally it takes a lot of time in making his presentation. So that is the reason for which we leave to him a little more than the traditional half an hour, but I really hope he can respect the time and be in time. So thanks anyway again to both Fabrizio and Andreas for their contribution in preparing these sections. Fabrizio, the floor is yours.
Thank you for this very smart and hot presentation, but I'm used, I know. Thank you very much, Paolo. And yes, in the title, there is the mention of climate smart agriculture. So today we are trying, I will speak alone just to save time in dividing the presentation, but everything was prepared in close collaboration with Andreas. We started from a consideration on climate smart agriculture, and we would like to present what is going on forage. And we anticipate there is a big problem on speaking about forage innovations. At least in the meaning we usually give to the meaning of innovation. So there are innovation, but with some problems. Starting from climate smart agriculture, we suggested to see this publication because is from the FAO of 2015, in which the content of the principle of climate smart agriculture were listed and discussed, and they refer to the problem of the interaction of climate, adverse climate situation, with the practice in agriculture. So the book provides a lot of implementation strategies, but these strategies obviously must vary from country to country according to the level of technology they are available. So we try to focus on what is going on in, let's say, developed countries, avoiding situation of very extensive practices. And in short, in developing countries, the climate smart agriculture matches the problem of climate changes with the so-called, what is addressed by the so-called Industry 4.0. That we started to call at the end of the last century precision agriculture. And we can we can summarize this principle in 4 points: improve farm management, necessity for traceability functions, meaning that we need also in all the agricultural sector product and process certification, obviously environmental sustainability, and also the needs for automating processes. That is the main focus of precision agriculture with well-known site-specific farm management approaches and so on. So there are a lot of strong analogies between the content of precision agriculture and climate smart agriculture and the Industry 4.0. What are the common targets? You see that, let's say, the keywords of Industry 4.0, process digitization, automation, hyperconnectivity, calling for IoT use, treatment of huge amount of data, so the problem of big data related to even quick data interpretation and machine learning. But there is even an evolution that was even mentioned yesterday in the first presentation, I think, Industry 5.0 and smart agriculture. Smart agriculture can be seen as an evolution of precision agriculture with new keywords, responsible innovations, human-centric approaches, obviously environmental sustainability, and even resilience. Everything was well presented and already discussed yesterday, but here we have to retake into consideration this, this aspect. And everything, as you can see, matches the objectives of climate-smart agriculture. So if we want to go on with a comparison with agriculture and industry, why Industry 4.0? You see upper the step of evolution of industry. So industrialization, industrial consolidation, digitization, and cyber-physical evolutions. The situation of agriculture was totally different. At least this is mainly referring to the Italy conditions. We had a long period of tradition in ruralism, so without any type of mechanization. A long period with motorization, so the introduction and the substitution of manual labor with tractors. Then a mechanization step follows for a period lasting more 20-25 years, starting from the 60s of the last century, and then from the 80s, humanism and electronics. You know that I'm not speaking about information technologies, but mainly focusing on humanism, so safety, for example, for workers, and the introduction of electronics. And starting from the 2000, the end, would be better, the end of the 90s, precision farming application and so on in the last period. All the contents you see here about what we usually call precision agriculture, already discussed also in some presentation of yesterday. What happened about forages? So, a first consideration, if we want to analyze the effort intensity in the innovation of forage mechanization, and even including also conservation process, you can imagine a situation like this. So, they started with the mechanization steps in the 60s with the introduction of new implements specifically thought for forage harvesting. Initially with a strong focus on flatlands, then we had an intensive period of innovations also on conservation process, and then more or less starting from, let's say, in the 90s, the middle of the 90s, there was a decreasing in the interest in introducing new solutions. And now we are in an almost steady situation, with a focus on steep lands and mountains regions. And now we have a situation in which we can analyze the persistence of incremental innovation, mainly related to punctual aspect of the production chain. So, some key points at this point. If we want to actually introduce smart agriculture applications, we need to speak of a paradigm shift in the farm management way of conducting the farm. So we need the introduction of farm management and information system, already mentioned. What is the problem? The problem is that in agriculture, we didn't have the analogous of Industry 3.0 step. We didn't have the information revolution. So we have a gap to recover. And we are still suffering about this gap. In the period of the 70s, the industry developed the so-called enterprise resource planning, the ERP solutions that are the use of integrated information systems, not so totally diffuse also in the industry sectors, no? But anyhow, they have a great experience on this, and this experience is lacking in the agriculture. And now, many of the problems we have in introducing precision agricultural technology just derive from this step. So, what could be a solution? Designing a new generation of farm management and information systems, already mentioned, tailored to the limitations and peculiarities of our sectors, of the agricultural sectors. And here we want to stress the fact that the concept of such systems should be designed starting from the conceptual role, so a conceptual model, that each component that we can introduce into the system can play into the transformation of this, the cycle data, information, decision. Also yesterday we heard farm management, data management. These terms, if are not well explained, could create confusion. Also when we have to pass to technology transfer step. So our proposal is to frame the conceptual structure of a farm information system through 4 areas, starting from data collection, data processing evaluation, data processing, data evaluation, information use. In each step, the data are step by step transformed in a way that they can enter into the decision-making process and to usefully enter into the process execution step. This is an extended view of this concept. The green part is related to the easier application of the technologies. The orange part, processing and evaluation, is more complicated because requires higher interactions with information technologies. And the user is not aware to this practice. It is simple to use an automated solution confined into a machine. It's not easy to speak about data processing, but mainly data evaluations. What Arne mentioned before, there is a lack of joining some data when you collect. This is a problem of evaluations. And the evaluation step can play a relevant role in farm management, and nowadays is largely not well considered. So just an example of related site-specific fertilization, in this case related to grassland, but is valid for any site-specific. So you see the 4 steps. Where is the starting point? Obviously, historical data. We want to use prescription maps, so the historical data are provided for constructed the maps. The maps are transferred into machines. Machines are used to execute the process, and while the process is executed, they should implement also a spread monitoring. So they collect the data to compare what they actually did when compared to the expectations, what it was planned, that was in the prescription map. And this spread monitoring, what we actually did, is then used to update the historical database and also to provide spread traceability. So you see as a simple application, okay, let's say conceptually simple applications, not simple in practice, but implies a large spread of role in each of the first steps of the conceptual information system. What are the digital implications? If you want to analyze the problem of managing of digitalization of agriculture, listing these 5 criteria, so financial and economic solidity, the necessity to work in contexts that should be better contained, limited, easily controlled, the presence of repeatable production processes, the presence of professional staff and highly skilled technicians, and internal availability of ICT skills that are the requisite, the needs for any Industry 4.0 application. For the industry, we have this situation. 3 balls means 3 strengths or strength point or 3 strong opportunities. If we want to reason around crop agriculture, but focusing on crop production and crop forage, the situation is dramatically this one. It's exactly the opposite. So we have 3 critical, 3 balls, so 3 critical situations on all the points. Obviously, when we analyze the situation of animal husbandry, it's different because animal husbandry is a production system more similar to industry. We treat biological means of production, the core, the animals, but there are some points that are quite useful, and that's why the digitalization in agriculture just starting mainly from animal husbandry. We still have some problem, obviously. And if we speak about contractors, just to have the comparison of all the actors in our sector, we have this situation. So even with some strength point, better than simple agriculture, but always with some criticalities. So how to approach this problem? When we speak of farm management system, we speak of a variety of technologies. So you see sensors, identification systems that are not so frequently mentioned, but they are strictly necessary. Obviously actuators, obviously positioning systems, and ICT solutions, the so-called software, no, to manage data and information. And if we want to analyze the way of producing something, the enterprise, in this scheme, we have balls indicating materials, final input, intermediate or final output, and this scheme, this is derived from the Forrester representation of the 70s, quite old, is nothing used, just with the distinction of a stationary user point or mobile user point, so machines or plane in our case. It is interesting to see how, in principle, this technology can be distributed among the necessity of monitoring materials, monitoring machines, and the related technologies. Keep in mind, any technology should be then integrated into the farm information system. That's the point. So the point is how to integrate all of them. And this is just an example of what we could register, but what is important is that if we focus on materials, we are speaking about product certification. When we focus on machines, we have the focus on process certification, but both, they should be nowadays considered, also in forage production. And the view of our enterprise. So when we speak of animal farm, this is our working context. So forage crop that establishes a circular equilibrium, three independent production sectors that must be in equilibrium while respecting a strict balance of materials. When the balance of material is not respected, we have problems, for example, in slurry production. So forage crop, animal husbandry, waste management. Keep attention that in this representation, we highlight the difference between green forage and conserved forage, and the interaction between conserved forage and concentrates integration that are composing the diet. What is the problem? Each system is studied in an independent way. And there is a system, the blue one related to haymaking and the production and conservation of forest, that who does hold the system? Forage crop or animal husbandry? Keeping in mind that we even have to consider waste management because we have even to evaluate the distribution of organic fertilizer to close the whole cycle of forage of the animal husbandry. And so this is the view of just an example of introducing also the processes with the related colors. So you see that the integration is quite complex, and what we call haymaking lines implies several interactions with the forage crop, animal husbandry, and everything is in the middle. So some implications must interact and must consider what are our targets about quality of products, but keeping in mind that we should also look at the work organization and the productivity of our technologies. In this context, it's quite difficult. So having a so confusion situation where one point is one process is affecting another one, and so on, to speak about a radical innovation. So a revolution is very hard here to be expected. Better we can focus on incremental innovation because they are favored, because they are simpler to be applied. Just some old ideas. I was a student of when many of them were proposed, no, probably also a child, buffering. Buffering is a patent of 1960s, so I was a child. And, but these are just examples of possible radical innovation. These are actually radical. The so-called superconditioner, the buffering systems. I was joking yesterday with Bodria that I remember an old image of him very, very young in the field testing this type of machines. The Steckend also. The Steckend probably is the only one that has the also commercial. This is the model of the Aston. And there is also a second-hand market about this machine. It was interesting, but then it was left as well for other solutions. What are the common problems? Common problems related to uniformity of products, the nutrient quality, the nutrient contents, so the quality, difficulty in handling. This is one of the problems, so in work organization, and integration with subsequent operations. So if you want to describe what is the state of the art, these are the list of the process nowadays available, at least in Italy, but I think in the region of Europe, we know. So firstly, we distinguish between bulked forage and baled forage at harvest. So unpacked or packed solution, and there is a big difference in the preference of the farmer. Blue and green indicate silage production. Green is hay production. So we divided the technology and the process between silage and barn, even considering the diagram you see there is the moisture at harvest. So everything is planned to harvest as soon as possible to avoid losses in the field. The blue part in the diagrams on the right part is the risk. To anticipate too much can be risky for the quality of the forage, also for the safety of the structures and so on. So what are the priorities? Obviously, as you can see from the picture, which sector could take in charge of the problems? Forage or animal husbandry? Obviously, the needs are very, very clear, qualitative and to preserve, to mitigate qualitative and quantitative losses. Even acting on single processes is quite important. So also working on incremental innovation. Anyhow, we cannot omit to consider the attempt to get an optimal work organization with the reduction of production cost, also with a look to safety and environmental aspects. And the necessity to introduce also in this, at this level, advanced process certifications task. So if we want to move, we should have a look to the integrated system with all the three sectors considered in a while. It's not easy, but nowadays all the technologies available that were not available 20, 30 years ago permit the current ICT solution enable easier digital control of the processes. So nowadays our work is simpler from this standpoint. And also the transfer between sectors is, to be same, simpler as well. Obviously, we need even to implement, to develop a solution with a focus on worker safety conditions, especially in mountain areas, that is still quite critical. And the monitoring was mentioned also before. is a strong need. Monitoring the quality of intermediate and final products. So focus on moisture. Moisture won't mention. Many constructors disregard the monitoring of moisture. Is quite important, and we have a large aspect to develop technologies to be same. Energy, also energy consumption, and nutrient content. This is an hard task because the technology, near-infrared technology is more complex, but this is another front in which we could apply and we could develop technologies. Two words about losses. This is, don't worry about the formula. They look complex, are quite stupid and nothing special. We need the variation between fresh and conserved. And to be same, we can speak about quantitative losses when they are related to dry matter. So we lose pieces of materials, and the depreciation of the nutrient content we can have, for example, about energy and protein, that are the two words more critical, per kilogram of dry matter. So we have some indexes. What is interesting is that if we speak about total quality losses, we have a composition that is given by the formula, and the composition can lead to terrible numbers. This is an example, just a list of possible losses, very also tested in the field. We can reach up to 30% of dry matter. This is quantitative losses, about hay production, sorry, in this case, with the haymaking, conventional haymaking. But if we analyze, for example, a production of 5 tons per hectare of alfalfa with 22% of protein at the fresh forage, at the end, assuming that 25 and 20% respectively for dry matter and good protein, we arrive to evaluate a total losses of more than 440 kilograms of crude protein per hectare, that are corresponding approximately to 2 tons of concentrate per hectare. So the numbers are terrible, and this is a great problem. Losses could be analyzed also through twin models. Nowadays, another technologies available today is the implementation of twin models. Working on useful database and so on, we can also simulate what are the losses we can expect according weather, specific weather condition. This is an experiment we carried out on alfalfa, which has been affected by a rainfall 2-3 hours after cutting in the mountain regions. The blue line is moisture, the trend of the moisture actually measured with a continuous sampling of the product, and the red line is the simulation. Many of these data were based on experience of roads from the States and other experiences we carried out in the north of Italy. The 3 points are the validation checks. So we measure actually the losses in the field. It is a quite complicated task because we have to distinguish the steps, we have to recover everything in the field. It's not easy. So I think that the error is not trivial here, but the results were very happy. So we can imagine to have a situation of losses to be simulated also through theme models. So also this type of approach could be a useful tool, for example, as introduction in a farm management information system. The situation is not happy also for silage. This is an experience documented in the UK about bulk silage, so in horizontal silos. It can reach almost 50% of the losses. Here we have even the problem of leaching. So the humidity at the harvest and the risk of contaminating the product at the harvest when you are uploading the silos are very, very high. And the result can be a disaster. What I see here is a disaster. We produce 100 to collect the half. So it's a nonsense. About silage, there is the possibility, according to the type of machine used during the harvest, to have also an expectations of the losses controlling, for example, here, the intensity of the cut, so the size reduction, the compression we can provide into the silo, and also imagine what will be the feed rate, so the uploading rate from the silo. And here there are experiences mentioning that also these aspects, if well conducted, could be useful to maintain under control the losses in silage. So some quick mention to technologies, old also in this case, but still applied. Solar band drying. This is the first one I want to mention because it's not young, obviously, but is one of the most important change of paradigm that was introduced to increase the quality of hay forage production. There are obviously many problems, investment, energy consumption. Obviously, these are justified only if coupled with an air solar collector to be installed on the roof. There are even perplexity in this solution for dealing with bulk forage. The farmer generally prefer packed forage. But there are still margin to improve the post-harvest mechanization chain. A reasonable compromise could be round bale drying. It seems that there is an increasing interest again towards this type of solution. In this case, the mitigation of losses is lower because we lose more. There is, in addition, also the risk of homogeneous drying. They are suitable just for bales produced in a fixed chamber, not a variable chamber. No? Moderate investment and additional post-drying work required to be same. But they are appreciated, but we are working on baling. I want to mention for both this technology, the need to introduce also, and this is a call to all the researchers here presented, we have to start to deal with BIM tools, so the so-called building information models. These are methods for optimizing the planning, implementation, and management of construction with the help of IT infrastructures. So it is quite used in the other buildings sectors. We have to introduce also in agriculture this type of tools because they integrate easily the function of controlling and designing and controlling any type of plants into the farm management information system. So this is, I think that in merit to this, we have a lot of work to do, very fruitful also for introducing technologies. Wrap day, also wrap day is an interesting evolution, not new as well, but evolving with, for example, in combination with the baler. There are some mistakes in the use of this. For example, here in the north of Italy, they are frequently left the wrapped bale in the field. This is a disaster because they anyhow require a protection. So, and one of the main problems connected to this solution is the enormous amount of plastic that we are going to produce. And this is against the principle of environmental protection. Digitalization of large big balers. We have also two awards in this edition of EIMA. Generally speaking, square bale should be by contractor more favorite if compared with round bale just for transport and storage advantages. But at farm level, round bales are still preferred. So the two awards are related to round bales, if I well remember. What is interesting here, an incrementally solution, is the introduction of digital tools. So sensors I mentioned before, generally connected to isobus, that can enable the list of regulated differentiated pressure, for example, prevent to work in not suitable materials. Not all the models introduce moisture measurement, but someone is considering this aspect. Correctly those additives to improve the quality of and the shell life of the forest. So there is a large improvement also in this step, always with the problem of connecting, as already mentioned by Turner before, this information to the farm information system, and this is a problem, still a problem. An interesting, more recent means 15, 20 years ago, the belt rake. So to reduce the problem of raking, of rakes that are mainly when the operation is carried out at a moisture lower than 40%, we can arrive 10% of losses per treatment. That is incredible. The belt, so the substitution of a mechanical tool with a belt moving the forage is an interesting solution, providing very interesting results. We assume that if well done at the right moisture, losses are lower than 2% per treatment. So this solution is destined to increase also in the mountain region. You see there some solution implemented for the mountain region. Heroic farming forage. Yeah, we have a different solution for forage production on harsh environment. They were developed recently, in my region are quite common. The cost is sustainable. Anyhow, risk and social sustainability must always be deeply evaluated. It's not so simple, also having at our disposal this machine. Other solutions are related to animal protections. This is a solution produced by Pottinger, detecting with the optical sensor the presence of animal before cutting and stopping the machine in the case of presence of animal, and also studies about insect protections as are going to be developed. I am more mitigated towards this topic, but was mentioned also yesterday when we spoke about regenerative agriculture. So I think it is correct to mention also in the case of forest production this type of problem. And obviously all the innovations related to monitoring, crop monitoring with different sensors and with development of machine learning techniques. For example, here to provide, this was an experiment carried out by Andreas, about the grass distribution before cutting, also with the list of species present there. So this is a valid instrument integrating what Turner was saying before. But anyhow, we need still the integration with the farm information system. So robotics, just very quickly, and I'm going to finish. But it's time for a coffee for Paolo, I understand. Robotics, probably you have seen these solutions. They are interesting mainly for prohibitive lands, but it is hard to speak about robot. These are rather teleoperated machines. Teleoperated. Robot is a trend, is a brand. Okay, no. We are still at the level of teleoperated machine, but robots are present in this sector, but only with small machines for gardening. They are actual robots, but like the robot we use at home for sweep the floor, but it's different. It's not our case. So in this case, we still have to work a lot. You see the TRL index is not so satisfying. And there are other grassland management and grassland application, for example, a robot rake, a robot baler. The robot baler is Chinese, with a very low TRL that are going to be developed. But anyhow, the problem of robot in our sector is to face the problem of the strict regulations the use of a robot requires. And these regulations are stricter for grassland management because we usually have to deal with a very large portion of lands. So we have to wait the evolution of the regulations and of the safety measures. And obviously also robots will require a further adaptation to the farm information system with new requirements, new tools to be introduced. So the conclusion, just are we available for a smart forage system? This is a provocation. Smart Forage 5.0 is just is a brand. Yes, but we have firstly to distinguish between intensive and extensive agriculture. And intensive, for example, what we have in the Po Valley, extensive, what we have in the mountains. Anyhow, we have some common objectives that could be followed with different strategies, obviously. Here there is fodder quality, the selection of optimal cutting time, the necessity of reseeding, preferably also following a site-specific approach to maintain always at a right vitality the production of the grassland, to introduce more monitoring solutions to satisfy the aim I mentioned, and also having a look to the robot development, as I just told. Yes, but, so, okay, we could be ready. Obviously, there are some problems. If we want to search for radical innovations, obviously, we have to approach the problem considering all the sectors I mentioned: crop, husbandry, and waste management. We cannot omit this general approach. And then we have to study how to approach the actual and feasible introduction of the farm management information system. Keep attention that here I don't want to speak about software. It's not just a problem of software. Here we are speaking about information technology infrastructure. Is something more complex because we have to integrate a lot of components in this task. And in short, these components are related to monitoring and controlling activity. Obviously, this adaptation must consider safety and environmental protection with certification and traceability approach. This is not anymore postponable. And at the end, I would say, if you really want to speak about a radical innovation in the sector, also keeping the conclusion of Turner, we should identify a new international standards for permitting this transfer of information and this integrating approach among components within an information systems, possibly with analytical functions. So the evaluation, you know that the evaluation steps of the information system is the most critical one. And in this evaluation step, farmers should be supported by external devices via cloud computing services. This is the evolution. There is a lot of work to do. I think that the constructor could play an important role to the same, but the road is still quite long. Not terrible, but we have to work all together. Thank you, and sorry for my longness.
Thank you very much, Fabrizio. You have been quite in time, so sorry for my not really polite introduction to you, but You know, so we are really friends from a long time, so I think it's not a problem. So now it's time for coffee break, and please try to be in time. So I give you 50 minutes, but not more. So be here 15 past, 15 to 11, not later. So, thank you, Marco. Now we move to the third speech of this section on technology for grassland management. We have, as normally, we have as a third speech of these specialized mechanization sections, a presentation made by industry. In this case is Kuhn Company. The title is Forage Implementation Solution Trend and Visions. This is a presentation that has been prepared together by Joseph Tard and Paolo Cera, but is presented by Victor Meyer, that is a product manager of Kuhn. So Victor, please, the floor is yours.
Okay. Thank you very much. So, good morning, everyone. So, first of all, thank you for Club of Bologna for the invitation. It's an honor for us as a Kuhn to be part of this meeting. And I hope my insights and our vision will help you to bring something new in this discussion. So, I'm Victor Meyer, product manager for Kuhn Group, especially on hay and forage products. And I also would like to thank you, Mr. Tar, my colleague, product manager too on hay tools, and Mr. Paolo Cera, which is marketing manager for Kuhn Italy. They both helped me to prepare this presentation. So the topic of this presentation is mechanization trend and vision with new challenges in hay and forage harvesting. I will start with new challenges because today in our world we see many challenges for farmers, and these challenges, these new parameters to consider really affect the development of our machinery. So the first parameters to consider is the type of crop harvested today. So compared to many years before, our farmers only harvested the grass or silage or hay grass, but today there is diverse and different varieties of forage: alfalfa, sorghum, Sudan grass, rye, etc., etc. So farmers try to devise to harvest different type of crop because there are different purposes. For example, yield, time to harvest, quality, protein content, also the climate. So they try to adapt their crop to their condition and to their purpose. So that's the first parameter. So machinery needs to be versatile to work in this diverse crop. We don't have the same volume, we don't have the same quantity. If you compare normal grass to a rye grass, for example, so we need to have versatile machine. Second parameter to consider is the weather. So we have seen in the last weeks, in the last months, in the last year, diverse weather events. So flood, dry. So farmers have to adapt their work method to the condition, and they have to be prepared to the diverse condition. So for a year to another, weather condition can be totally different. So from drought to flood. So also the weather window are shrinking. So we need to adapt our product also to this diverse climate condition. Third parameters to consider is the crop goals. So we see today that crops are not only used to feed animals, so to produce milk or meat, but more and more there are different purposes to the different crop. So for example, today we can see some farmers harvesting crop to create energy. So as you can see on this picture, for biogas plant. So that's very important for us that we consider different purposes of different crop. And here also we need to adapt the material to these different purposes. So for example, farmers don't have the same demanding level if they want to harvest quality or if they want to harvest quantity. That's really important to understand. Last parameter is more field size are increasing. So as we say in the previous presentation, the farmland are more or less the same through the years, but we can say that there is less and less farmers in the world. Young people don't want to be farmer. So it's really, really difficult to find young people to farm. So there is the same level of land, same quantity of arable land, but less farmer. So farm size are bigger and bigger. So we need to have also bigger machine to harvest this quantity of crop. But in the same time, as I said, there is less and less people, and also less and less skilled people to work with our machine. So we have to adapt the material to not only be efficient, but also bring some comfort to the driver and to have an intuitive machine. That's also an important point of our development. So we have seen different parameters, new parameters in this world. So how these parameters impact the development of a machine. So as we said, there is more and more field to work, and farmers are looking for increase their capacity, to increase their output. So it's really important for us to develop and design a big machine with a large working width. So that's the first point, but also more capacity. So as you can see on this slide, there is different examples of big machine that are working today in different fields around the world. So large square baler, large tethers, large merger. So it's very important for us and for farmers to use big machine to have a good output and good and big capacity. So it's a real challenge for us to create this big machine because you need to create and design specific components, specific parts, but at the same time you also have to have compact transport position. So it's a compromise between the working width and the transport position. So it's a real challenge for engineers to create this or such machines. Technology is also important. We are developing new technology to face and to meet the needs of our customer. So here we have the example of our large square balers coming for Gelderop in Netherlands factory. So there is a new technology, patented technology with a double or dual piston system, and this technology or this system helps the farmer to reduce the fuel consumption. Because we divided the piston reduction of the piston movement, we are able to use a smaller tractor, so we will save fuel and then save money, of course. And this system also helps the farmer to create bale which are 25% denser compared to a normal system with a single piston. So we have seen large machine with big output, technology, but we need also to bring new concepts. So we have seen in the previous presentation the development of a merge max machine. So here it's a reality. It's a case today. Kuhn is a pioneer of development of this type of machine. So we started this type of machine 20 years ago in the USA for alpha alpha plant, and today we have seen that this type of new concept help the farmer to produce better crop quality. So as we have seen in the previous presentation, this type of concept helps to reduce losses and increase the crop quality if we compare to a traditional rotary rake. So we also need, when we develop new products, to think about new concepts. We don't need to or want to stay in the same concept as today. We also create new machine concepts. We talked about automatism and automation. That's also the reality today to help farmers to control data, to bring data, and to have more comfort to pilot the machine. So here it's a concrete case. So you maybe have seen it in the showroom. This baler has been awarded this year at the EIMA show, and we bring to the farmer the possibility to have an automatic baler. It means that this baler, the VB 7100 series, integrated different technology. First, section control. So it's the first time in the world that a baler has this technology. Section control helps to automatically lift and lower the pickup at the headland. So the farmer, it helps the farmer or the driver to gain in comfort. And these bales also have the team function or the team system. So the baler will pilot the tractor. It's not the tractor which pilot the bale. It's the baler which pilot the tractor. So the baler is able to say to the tractor, now you need to stop. You need to open the gate of the bale, and then you have to restart the work. So with this type of system, with this type of technology, we are able to say that we will bring more comfort for the driver. We don't require high-skilled driver with this type of machine, so it helps also to offer this product to a large amount of farm. And yeah, that's more and more the case. Agriculture 4.0. So we spoke about it in the previous presentation. More and more farmers want to collect data of the field. They want to know the yield of the field and the production. So we are developing different software, and here you can also see it's also the case with the baler, the same baler as before. So we are able to collect the data, so where the bale is located in the field, what is the weight of the bale, what is the moisture rate of the bale, and thanks to this system, we are also able to transfer all the data from the machine to the computer. So the farmers know in the field what is the yield in live, but also in the office. And then in the office, he is able to analyze and to merge all the data from his field. It's also important for contractor. They are able to put a name of the customer and to put the field name. So we are able to say, in this field I have this yield, in this field I have this yield, and it's really important regarding this point. So that's for the impact of our development. Now regarding futures, of course, we will continue to embed the technology, so we cannot come back with less technology. Even in small machine, so we have seen big machine with a large output, but we need also to consider small and basic machine, because sometimes fields are too small to work with big machine. Small farms with small and basic machine will also request for a lot of technology to also gain productivity and to gain comfort. So you can also say that we will bring more automation, more automatism in our machine, but also more decision support system. That's really important for the farmers, that the machine is able to help him to make decision. Of course, reduce energy consumption. I told you that we are still working on it with some example, but more and more it will be mandatory for us as manufacturer to produce a low power consumption machine because of the legislation, but also because of the social pressure. So we need to consider this parameter and to go further with regarding this point. And finally, robotics. So this is for sure the next big challenge for us as a manufacturer, because as I said, there is less and less farmer, less and less people to work, so we need to have machines that are able to work alone or automatically. So it's still the case as we can see on this EMA show. There is a lot of robots, but in grassland it's still the beginning, because there is some limits. We talk about it, legislation, safety, and also we can say output. It's not the case. For example, for seeding, you have 2 or 3 weeks to seed your field, but for grassland, when it's time to cut the grass, you cannot wait. So you have to cut the grass immediately, almost immediately. So we are facing some challenges with robotics, but for sure it will be the future. So to conclude this presentation, we can say that of course technology will be the future, and the future of mechanization lies in smart forage management. That's a true point, and that's the reality. Thank you for your attention.
Thank you for this presentation. We now have some time for questions. Again, probably they can hear me, who is connected from outside. They can send the questions to Danilo Monarca, as yesterday. We have one. Maybe you can start with this one, but the floor is open for any questions. So as you remember, we have a free presentation, so you can start without any specific order. So just get up your hand and I try to sign who is the first and the second. Professor Reinius, the first one.
What about wafering? What about wafering machines? Many companies started again and finalized, and what is your evaluation for the future to develop machine which produce wafer from alpha and so on?
As I mentioned, is an old project. The patent is about 1960. The wafering, the first model. No. The problem of the production of wafer is not in the process of buffering itself is rather than in the management of buffer in the following subsequent steps related to harvesting and storing and then downloading and distributing the buffer. So that was one of the main problems at farm level. I'm now speaking just about farm level. Buffering has some application, also pelleting. We saw some images before. Pelleting, no, is the same. The technology more or less the same in the industrial line. For the industrial line, is largely applied, but we are still speaking about industrial machines. So for the industrial of concentrate productions and so on, not for farming, not for farming. There are other types of problem. And I remember another experience I had in Braunschweig at the time of John Matthews. They were developing not a buffering, but something similar, a super densing cylindric baler, rolling. But then it was left. It was very interesting because I went to Braunschweig to visit. I was impressed. Now, yeah, very long, you remember, no? But Weger was interested then in the development, but the project was left because the size of the cylinder, the diameter, was too slow. They tried to enlarge to 60, but the pressing value was lower, and then the project was left. Just for problem in work organization at the farm level. Krone? I don't know Krone, the model.
I mean, this product is on the market, and I think it's picking up in being used actually, but mainly also for straw. But where we have in grassland a deal in that is with our re-wetted peatland, because there we can't really produce feed, so we should produce biofibers, and therefore I think this type of machinery will really be needed to produce these COPs or whatever you call it, for the industry to have a more defined raw material for bioeconomy.
Other question here from the room? Yes, Joseph.
Well, thank you for those presentations. I was really overwhelmed by all the information, and I think maybe I just became aware of how little I know about it. But yet I can have some questions, and I see that there is the variability. The variability, because you talk about precision agriculture, there is a variability in the field, and of course, then you get the variability in the final product that you are going to feed, and then it depends on the aggregation level. How much you put together on how you handle that, because you may then, for each bale, have different concentrates, quantities of concentrate to mix with it, to satisfy whatever the needs of the animal. So how will we handle that? Because that puts another challenge for the farmer. And then we have those bales. Some things happen in the bales during the fermentation, which could be completely different of what you expect. Okay, this was a comment, but maybe you also have some answers for that.
You want to answer, please?
Yeah, thank you for this question. I think on some point it was shown a little bit that we need in the whole process chain even the informations about the quality content for the final use. So for instance, raw protein, raw fiber, like even Stefan mentioned in his presentation, and this changing contents from process step to the next process step up to the mouth of the animal, let's say, has to be documented in the whole farm management information system from step to step, even to get the information where are the main losses in quality and quantity. Maybe you add some?
Yes, I would like to add some because when you look at what are we feeding today, so we go out there on the silage stack, we take a sample, we will then get a laboratory analysis. First of all, the sample, it's mainly 1 to 3 times we pull the plug into the silage stack, so it's not representative at all. And then we calculate our diet for the animals based on dry matter content. And then we open up the silage stack. We have weather conditions every day, it's different. So on this silage stack, actually, when we take out the grass silage, we will have a different and really dramatic shift in dry matter content of what we take out of our silage stack, because there was a windy day, it's dried off, so it's quite higher dry matter amount than on a rainy day. And then in our feeder mixer, we put in always the same amount of material calculated from our calculation from our laboratory analysis. So exactly we feed different stuff to the animals every day. And there were experiments that have been done that showed only by adjusting the dry matter content to the real calculated ratio for the animals, you gain half a liter of milk per animal per day. So such a near infrared sensor is paid off in a large farm, so that was a farm with 2,000 cows, within 3 months. But no one's caring about it. That's again what we have a lack in with managing grassland and grass feed stuff.
If I can add just a remark is what I think what you raised is a typical logistic problem. So where is the pack of forage I'm using, in the, which position is in the storage, and what are the need of my diet that I have to produce, to compose. And this highly depends also on the technology we didn't mention, but the technology of how to mix the forage. For example, Unifit. See, if you use Unifit, you have an approach, you can have an approach. If you use other types, if you distribute separated, you can follow another approach. If you use a bulk silo, you need to know the position in the section. If you use bales, you need to know the position of the bales. If you use a barn hay, you need to know the level in the height of the hay. So it's a typical logistic problem that must be considered inside the way of distributing. So it's a typical agricultural engineering problem that we could have the time also and the interest to face.
Thank you. We have another question, please.
How about the request to the harvest and to the ingredients of grass when it is harvested for biogas or for biofibers? So we are talking most of the time about use of feed for ruminants, and we all know that ruminants are under high pressure of consideration of methane emissions. So will be the use of grassland for biofibers and for biogas a future use of grassland? To Andreas Gronauer.
Okay.
Andreas.
I think what we have to face, what will be the overall goal in animal husbandry, in ruminants, because one strategy, as I understood, with the question of intensification versus extensification will be to increase the amount of milk which can be yielded by basic diet. So let's say the fodder we are talking about. Yes, and so that means if we take into account the crude protein content, the megajoule netto energy lactation per kilogram dry matter, the quality parameters of the fodder, and yeah, and with biogas there are similarities in a way, but some differences in the requirements. So, for instance, the acidification for instance, so that you have an acetate lasting conservation. For biogas plants, it's no problem, but for ruminants, it would be a big problem, of course, because you have to manage the silo in a little bit a different way. Yeah. But nevertheless, the main goal, what I want to mention is, if the main goal would be to maintain the grassland in the cycle, what Fabrizio mentioned before, in the cycle, which includes later on a sufficient management of nutrients from the organic fertilization, that means in the end even a reduction of concentrate. And a reduction in concentrate needs a paradigm shift in the genetics, in the breeding programs, even there. And that is something what is really a complex approach, depending on the main goal a region on a local level is faced on.
Thank you. You want to say something more? No. So Danilo received 2 questions.
Yes, the first is a comment by Herman Auernhammer. Congratulations on this really comprehensive presentation. Compared to precision farming for everything that has to do with grassland, 3 basic technologies are needed and must be realized: dataset standards, energy harvesting system for animals to provide a lifelong energy supply for any type of sensors and the communication on the go, and the first, the location of stationary techniques and the stay of animal buildings must also be integrated with the unmistakable data. Only then can the FMIS shown be realized. This is a comment. And the second one.
Wait a second.
Okay,
maybe
if you want to comment the comment.
No, because the one is from Stefan, no? The second one.
The second one, okay, is this?
From Stefan. But now,
yes.
Now maybe they wanted to comment something to the comments. So.
Yes.
No, Andreas, you just want
I
to
can
agree?
only answer, my teacher is quite right.
Your teacher is quite right.
And Stefan Bottinger has a question to Fabrizio and Andreas. Thank you very much for this comprehensive presentation. What do you think are the biggest obstacles to finally implementing the technologies to reduce these immense losses? Thank you.
Wow.
Oh, sorry. And Stefan continue in another email. And what are you recommending? Where to start to overcome these obstacles?
Sorry, what?
Where to overcome these obstacles, sorry.
Losses can be controlled acting at punctual level, firstly. No? Punctual means controlling each process along the supply chain we are going to implement. So starting from moving, tedding, raking, and so on. In my personal suggestion is what I suggest when I was very active I was still in Milan, no, in the field. What I suggested was, whenever possible, to use a conditioner mover to increase as much as possible the drying in the field. But this nowadays can have problems saying that keep attention that conditioner increasing also the mortality of insects. And this is another aspect that now we have to balance. No, 20 years ago was not felt. Nowadays we have even to consider this aspect. But if we focus on the drying process, conditioning is a great improvement. Avoid as much as possible to use tether, only when strictly necessary. So associate, this could be possible, associating to the use of mover, the special mover able even to form a soft swath, so thus avoiding the necessity of moving and then to use the rakes that are able to ensure as much as possible the impacts of metal components, metal tools with the forage. So like the belt rake and so on. Obviously, there is the last step that is baling. Baling can cause up to 5% of dry matter losses. This is, if you want to bale, this is unavoidable, inevitabile, unavoidable. And you cannot anticipate the harvest with an higher moisture due to the risk of fermentation if you bale. So the alternative is to use the harvesting with fresh forage, so going into the directions of drying with all the related implications, rather than to use also round bales dryings. As far as silage is concerned, the quality of the work when you fill the silo, the bulk silo, if you are speaking about bulk silo, rather than other solutions, wrapping systems, please avoid to leave the bales in the field without any protection, with a direct contact to the ground. This is quite terrible. They can have a very, very bad surprise when you open the bale, with a lot of losses. You put away all the production of the bale. So there are some very small actions that you can do. These are all punctual, and but is not simple to ensure an high professionality to be same. Also, training could be an interesting approach to the same.
Just to add a short aspect, if we want to develop the technology on a, let's say, a more smarter level, the first thing is we need, in the entire process chain, we need more information, detailed information, and that, as I mentioned before, it clearly leads for the need to have access to an adaptable and suitable and robust technology to receive the informations. So that means sensor technology related to the ingredients, the later on important ingredients like crude protein, crude fiber, and things like that, which are known from the animal nutrition. That is a first step. If we have access in the different process step to this kind of informations, then we can adjust, because we get the know-how about where we have our big points in the process chain of losses and so on. So for instance, baling losses 5%, yeah, dry matter, still we are on the level of dry matter. But if you put beneath the baler a collection, what kind of fodder you lose? Okay, these 5% of dry matter, they are related to a absolutely high content of crude protein, a very high digestibility and so on, because it are the leaves. Yeah.
May I just a short comment? So I think we have many low-hanging fruits actually in this area of grassland management and feed management, and we're not able to pick them. And I think the farmers don't care that much about it. So my approach actually at my research is to put a price tag on it, on all these losses. And I hope that the farmers will realize, well, I'm losing money. So that's what I think would be maybe one way to really realize to reduce our losses, to put a price tag on it so that it's really clear for the farmer how much money he is actually losing with his actual practice.
Just to add a comment, for sure, we said that now the main challenge is to manage the data and to collect data from the harvest in the hay, and maybe to link these data to the mixer wagon, and so to move to the feeding machine. But my comment is just to say that, okay, this one is the main challenge, the data, but for the key message around the availability of technology, for example, to reduce the risk to cut and to collect soil or other things that maybe can really reduce the quality of the hay. These one are concepts that present in the machine. So it's a reality really confirmed with concrete solution, for example, in the cutting bar solution, in the to have a machine that are able to really cut in a very fast condition, but with no risk for the quality. So just to say that probably this point is now available in the innovation, the machine. For sure, the challenge is more now to the data, as we said, and maybe in our solution, in our company, now the strong challenge is to link the HAME family with other machine, mainly when we are inside the animal farm and the dairy farm. I don't know, Victor, if you want to add something.
No, as you said, as a manufacturer, we have to design our product to be more versatile. As I said, for example, for cutter bar, this year we have seen a lot of rains, a lot of water in the field, so we need to cut higher than normal. So we have to put higher skids to increase the working height. So that's why it's important to have versatile machine and with specific optional equipment to adapt to the condition.
Environmental conditions. Thank you. Very last questions, Andrew.
Yes, gentlemen, I have an observation and then a question. First of all, primarily aimed at Joseph. Joseph, what? Oh, Victor, I do apologize. I was reading off the agenda here. Yeah. I do apologize, Victor. So, my observation, based on speaking to colleagues, I spoke to my learned colleague, Mr. Eskil Nielsen, who, to my horror, tells me that in Sweden they have very, very few dairy cows. Hardly any. But the Netherlands, and we hear people have too many cows. And so it's to do with pricing of the balers. So you demonstrated this absolutely super duper baler that lifts up and down and drives it. And so when you start having the machine driving the tractor, your operator has comfort, your words. In my experience with auto steer in field crop machine, one of the things the operator says, the job has become boring because I have very little to do. And when you think of baling, it is not beyond the wit of man to understand to lift the pickup at the end of the row. So taking into the previous comment that dairy production, we have excess milk in the EU, we have a milk lake, just like we have a wine lake. The price of milk has remained very low in general terms. The price of beef, we have so much anti-lobby about our beef. And the other livestock you've forgotten to mention, not one of you, I would hasten to add, sheep. Sheep are great grazers. Price of lamb happens to be up at the moment, but it also goes into the trough. So for Victor, my question is, where is the market level for such a degree of sophistication? Because a lot of livestock farmers are relatively small. What is the price of that giant baler? And is it aimed at farmers or is it aimed at contractors?
Yeah, for sure, this type of products are not for all farmers. You need to make some hectares or some jobs to have a return of investment, because it costs more money than a normal baler, for example. But yeah, for contractors, it's very important to have such a machine, so with a lot of comfort, because okay, it's boring, as you said, it's less interesting that if you have different action to do in the cab. But yeah, sometimes the driver is also the owner of the company, so he has to make some call phone. He has different things to do in one day. So a day is only 24 hours. So, no, but that's true. Huh? That's the reality. Huh? Sometimes he's driving and then phoning at the same time. So it helps us. It helps the driver or the driver to focus on important task or added value task.
Okay, thank you. Okay, because there is also Professor Reinius want to. We are already 10 minutes late.
Maybe very short. I think a very important point to have to be taken into account is that grassland management isn't from the whole society perspective, not only related to milk or meat production. For instance, the photographs from the mountain regions, you have a lot of additional tasks the grassland has to fulfill, like, for instance, biodiversity aspects, wetland management, or even reduce mountain risk management, which is related to the grassland management in an economic scale. So we have to take even into account these aspects if we are talking about grassland management.
Yes, thank you. Professor Reinius?
A question to Joseph. No, you are ready, okay. We talk about 20 years about the principle of implement control structure, you see. Is this your system? Is that on the market? Can I order to buy it?
Now with the team system that I presented before.
Yes or no?
Yes. Yes.
Okay, thank you.
That's all. Thank you. So, thank you again to everybody. The speaker, especially Andreas and Fabrizio, for helping me in organize these sections. So now we are 10 minutes late. Also, the president is coming for the ceremony of Pellizzi Prize. So I just want to introduce you a little about Pellizzi Prize and also give the floor to the free winner of the Pellizzi Prize. Can we see this, the slide, please? Thank you. So, as I mentioned yesterday in my opening, we arrived now to the 5 editions. So, first one was in 2012. Just for who is not familiar about the Pellizzi Prize, Pellizzi Prize is an international competition that has been developed together with Accademia dei Gergofili, and here we have Professor Picarolo that will be also part of a composition of a member of the awards, and is entitled to the Club of Bologna founder, one of the Club of Bologna founder, Professor Pellizzi, and is reserved to PhD thesis related to the topic of agricultural machinery and mechanization. So what the Federonacom that support not only the club but also this prize is to allow it to the winner to become Club of Bologna members for 5 years. But not only this, there is also a money grant, I can say, support for this free winner of a prize. How candidate can attend the prize? So they need to have a PhD in agricultural machine and mechanizations on these specific headings. I don't want to mention. Maximum age of 37 years, and they have obtained a PhD title not after 3 years from the publication of the prize, that is generally made and published in due time by our General Secretary on the Club of Bologna website. These are just a short picture about the previous editions. So this was the first edition with the winners, Baguena, Pitts, and Navalade from India. The second one in 2016. You see that some of these people now are really part of the club in active way again. And also the third one, edition in 2018 with the 4 winners. In this case, we have the third winners that are two persons because the management committee decided to give the same possibility because he reached the same score was this two person, Fuentes and Grella from Italy. This was related to the 4th editions. Again, we are here some of these winner. And for the last editions, of the present editions, we had 12 candidates, 5 from the United States, 3 from India, 2 from Italy, and 1 each from China and Australia. The evaluation criteria that has been managed by the components of the management committee has been the same of the previous editions. You can see here the maximum score you can give to the document you receive, to the thesis, to the CV. We had decided last time to give a little more value about the quality and clearness of the presentations, because this is really something that can be read directly by the management committee members in order to evaluate and give the final score. So, according to what was the results of this evaluation by the member of the management committee, we have these 3 winners that are now in this room. This is just an alphabetic order, so they really, up to now, they don't know who is the first one, who is the second, who is the third one. This will be during the award ceremony, so I maintain secret up to now. But as is mentioned in the program, now I leave the floor to them because they have to make a short presentation, please 10 minutes, in order to leave for a couple of questions sometimes, so 2 more minutes. So try to stay in the time. And I start, if you agree, again, following this order. So Dr. He, if you want to start with your presentation, then will be Tian and then Xun. So please just follow this order in your presentation. But please try to stay in the time. Yes? The point that they need to narrow together. Yes. I wanted to mention this later, but you're right. So anyway, it was not easy to find the 3 winner because, as Professor Matthews Reinius say, the final score was very narrow between each other. So also the 4th and the 5 was not so far away. So it was really difficult to define the first 3. So the quality, this means that the quality of the contribution were really of high level. So this is something also of very, very value for the club. So please, who is the first one? You are the first one. The floor, yes, the floor is yours. Here you see. Last one. Please.
Hello everyone, my name is Zixuan He, and you can just call me ZIX. So today it is great to present my PhD dissertation with topic of effective robotic strawberry harvesting with a focus on the occlusion handling. Firstly, please let me introduce myself. I am currently the postdoc researcher at the Center for Quantitative and Genetics and Genomics at Aarhus University at Denmark. So I am originally from south of China in Guangdong Province. So it is in a very small city called Huizhou City, which is around 1.5 hours to the Hong Kong. And I received my bachelor degrees in automation from South China Agricultural University. After that, I directly went to the Washington State University with major in biological and agriculture engineering. Okay, let's begin my presentation formally. So firstly, let me bring some introduction. So the strawberry is native to the North American. So in the United States, there were several states for the strawberry productions, like California, Florida, Washington, and North Carolina, and also Oregon and yes. So for the traditional harvesting method, I believe for the most of the commercial or the industrial side, so they still rely heavily on the manual harvesting. So like in the harvest season, the worker, they need to go to the field, use the scissor or use the knife to find mature strawberry and pick them out of the stand or the canopy and then package them in the field. However, with the recent year, especially in the United States, there is a trace on the aging agricultural workforce and decline in the new labor source, so which bring the increasing labor shortage and cost. So therefore, so the robotic harvesting, so currently are seen as a supply to the manual labor or maybe the alternative in our maybe near future. So based on the concept of the robotic harvesting, which adapt in the field currently, maybe from both commercial and both academic, so there were three traditional methods or three popular methods. The first one is, I would say, as our traditional method. We go to the field, use the robot, we find the target, we pick the target. We didn't do any processing on the occlusion. So such problems caused by this method will be like sometimes the strawberry get brushed or the leaf or the wife get hurt during the robotic picking. So another method is kind of the difference between a little bit upgrade. So it is robotic harvesting with passive occlusion handling. So we identify the occlusion and then we trying to use the manipulator to control it in a right angle or in a right attitude to approach our target. So the final one is the method I applied in my PhD dissertation. I used the robotic harvesting with an active occlusion handling operation. I used the fan system to remove the leaf or wife or any kind of the occlusion over the target strawberry and then pick the fruit. So it consists of the three parts. The first one is for the strawberry detection, and the following is based on the strawberry detection. I use the machine vision system to conduct the picking decision based on the visual. And finally, based on different occlusion, and also I apply the robotic strawberry harvester. So the first part is more related to I use the AI-based tools on the conduct strawberry detection. Maybe for some audience, you might know very familiar with the AI or kind of this thing. So we can see as a function or a formula. The input is strawberry image, and then the output is the strawberry location with the bounding box and also with the label name. For example, like this is the mature strawberry. This is the nearly mature or the immature strawberry. So my work here is to conduct the processing on the modification of this neural network to let a more suitable strawberry task. So I just conduct like the modification on this network to let it more suitable for the strawberry detection. So for example, so this is the Euro V5. Its full name is You Only Log Once. It is a very general AI tube for strawberry detection or object detection. So for the original task of this kind of AI tube, it is applied for like the COCO dataset, including 15 different classics. However, in such work, we don't need such complex network structure. It means that we could make it more easier structure to let more fit our strawberry detection. So in here, I use a simplified module in the Euro V5 while maintain the detection accuracy. So the following one is a bit complicated. So it is the Euro V8, a more latest the Euro in the last year. So in here, I conduct I add a new head structure specialized for the small object detection, because usually the strawberry image, like in my formal image, we can find it is quite small. So it means that maybe it occupied the region some kind of the less than 10 plus 10 pixel. So in these situations, we need kind of the strawberry detection or the small target detection. And it is also similar. I use the simplified structure in the kit module to make more efficiency. So after when we have the ability to conduct the detection, it is time to consider whether this method really suitable for the real robotic strawberry harvesting. So we can see from the crop image from the strawberry, they have a different occlusion rate. So it means that we might couldn't use the same picking methods for them because there is occlusion during the harvesting. And then I also want to use the object detection in this step. However, my preliminary result just showed that because there were too many similar features of different leaves of the strawberry, so it will mislead the detection performance. So in this situation, we need additional recognized technique for conducting occlusion classification or conduct a picking decision to remove the occlusion, or we could try to avoid occlusion. So this is the whole workflow of the part 2 or the objective 2. So the formal part is very similar to the strawberry detection. We can find its location, and then another AI tube classification network to conduct the decision label in each mature strawberry. So it means that you could kind of make decision on this strawberry, whether it could directly pick or whether it is occluded by other part. We need other procedure. So after when our machine vision system have this kind of the adaptation ability or the decision ability to the strawberry canopy, and then it is time to conduct some strawberry harvesting. So my robots compose kind of the 3 main parts. The first one is the machine vision system, as I mentioned in the formal 2 part, and a commercial manipulator, and a self-design and effector with the soft gripper and also the fan system. So the fan system is attached just above the gripper, so it equipped with 12 DC motor and also adjust speed. So there is a 2 air tube for the direction choice, because sometimes due to some attitude limitation, the manipulator couldn't just adjust the angle or adjust the wind direction very smoothly. So here is kind of the air simulations on the strawberry. So here is kind of the simplified control algorithm. So I use another detection algorithms on the after this occlude strawberry. For example, if the strawberry bounding box will separate in different 9 grade. So after that, if the grade 7, they have the occlusion or any other occlusion, so the wind direction will just go through the direction 7 in here, so to remove the occlusion. So it is kind of the control related to the control altitude and also control the right angle to remove the occlusion. And finally, I conduct my experiments in a commercial size. I just compare the result without the fan system. So although it is very difficult to compare them, because sometimes I need to mention here they have the different occlusion rates. The final successful rate is improved by 15.8%, and the processing time, due to we introduced a new processing procedure, so it was increased by the 5.69 seconds. And finally, let me do the conclusion. In objective 1, I modify the general AI tube to the strawberry AI tube, and then in the objective 2, so I conduct the upgrade its decision, upgrade the machine vision system to let it have the decision ability, and based on this decision ability, so I apply the robotic harvester to have different act to the current strawberry harvesting field. And finally, so it is more like from the detection, visual size to adaptation, and finally conduct the operation. So due to time limitations, I couldn't bring whole the technical details. So thank you. I believe that's all for my presentation.
Thank you very much. I'm not sure that we have time for at least one question, but just one if it's really needed. Okay, just Professor Reinius, just
The
one.
speed of picking them compared to a good person who does it conventionally. The ratio. Is a machine as fast as one person can do?
No. So currently, I believe both the industrial goal, they are still trying to meet the 50% or 80% of the human labor. And because right now, so
a little bit less. Not a long story now. A little bit less probably.
Yes, a little bit less. So it's all done.
Okay.
No, I just want to say to you congratulations for the really nice work.
Yeah, thank you so much. So yeah, and also maybe sometimes one arm is so slower, then we could apply the multiple cooperation between the manipulator. That will kind of increase the efficiency greatly. Yes.
Thank you again. Thank you very much. So we move from this very nice presentation about robotics for pick up the strawberry to something related to energy saving, but especially hydraulic systems. So please, the floor is yours, Dr. Tian.
Thanks for the very kind introduction. Good morning, everyone. It's my great honor to be here. And my name is Xing Tian. I'd like to briefly talk about methods to reduce energy consumption in the hydraulic system towards the next generation of greener, higher efficient agricultural tractors. Well, a little bit about me. After graduating with a Bachelor of Engineering from Xi'an Jiaotong University back in China, I went to Purdue University as a direct PhD student and spent 5 years there, working on the sponsorship from CNH company of improving efficiency of tractor and agricultural machines. And after graduation, I joined CNH and currently now employed as a system model engineer working R&D back in USA. Let me start with the background and why do we look into the hydraulic circuit and why do we need to improve the efficiency of hydraulic system. As we all know, global warming and climate change is gaining increasing public attentions. And from a comparison between on-road vehicles, such as cars and trucks, compared to off-road vehicles, which includes agriculture, construction, forestry, earth moving, it has been pointed out that in EU, nitrogen oxide and PM10, while on-road is producing 42 grams per kilowatt hours, off-road vehicles is actually 46. And the other part for PM10, on-road is 2.5, while off-road is actually higher, 5.5. Well, a lot of attention has been paid to increasing efficiency and reduce gas emissions for on-road vehicles. However, less has been paid to off-road. And it is actually because they're highly variable duty cycles. However, there are a lot of similarities in their design, for example, engines and transmissions. Because of the heavy-duty characteristics of off-road vehicles, hydraulic power is still playing a very key part in supplying different functions and achieve the controls. From one study conducted by Oak Ridge National Laboratory, together with National Fluid Power Association, they have concluded that, on average, the industrial hydraulic system, the efficiency is 50%. However, when it comes to mobile, especially excavators, loaders, and tractors, they're the main players in the mobile sector. Their efficiency is only as low as 30% of the hydraulic system. This urges more attention to pay to improve such behavior and in such systems. Let's take agricultural tractor and take a closer look at the challenges incorporated of this work. If we want to improve efficiency and come up with high efficient and cost-effective solutions, a typical agricultural tractor hydraulic circuit is supplying multiple different functions and that includes traveling service, steering, braking, power beyond, and other auxiliary hydraulic functions. To have better performance, to optimize the component sizing, a foundation step is actually to understand where the power is lost, to characterize the power loss. However, that's not an easy job to do. The challenge here is the auxiliary supply circuit from the tractor to implements are very complex. Not only to mention their highly variable duty cycles, the ground condition, what work you're trying to perform, they all affect where the power is lost and how the power is distributed. Moreover, tractor alone is not enough. What tractor is trying to do is trying to giving the pulling force to conduct implements, cultivating, and other work in the fields. From a fully instrumented tractor and planter, and after performing experimental tests in Purdue Farm, what my team has found that the system efficiency drops to only 18%, which is much lower than 30% when they're put together. This challenge requires better integration between the tractor and implements to solve this inefficiency. And to give a brief interview, actually this inefficiency is because of the duplication in the control valve designs in both tractor and implements. A third challenge, facing the trend of electromobility to achieve a carbon neutral and more climate-friendly machineries, electromobility trend also applies here for off-road vehicles. If you look at the spectrum of current technology and full electric, we might agree that we are here. We do have some solenoid controlled valves. However, a doable step as a next step, going further to a bit hybrid, what we can think of, maybe we want to reduce engine, we want to attach more batteries. And another idea is let's electrify certain auxiliary functions for linear work, for rotary work. But then the question is which function to electrify? That's a third challenge. The challenge here, further investigation is needed on the power saving potential from different topologies of tractor auxiliary function electrification. To target these three different challenges, this research tackles all of them, having the one objective of to propose and experimentally demonstrate solutions and to provide insights of partial electrification potential on the tractor high pressure hydraulic circuit. The goal here is to reduce fuel consumptions and possibly lower the cost of ownership, especially for OEMs, for the next generation of green, high-efficient agricultural tractors. The reference machine here, thanks to CNH sponsorship, their New Holland agricultural high-horsepower tractor, coupled with Case IH 16-row planter. The approach taken here is a combination between experiments and simulation. We're going to build a basic model foundation of the system, and then we validate the model. After we trust the model, we're going to use this model to propose new solutions. After solution proposal, we want to implement the solution in the reference machines and see if it's promising or not. If it's not, or if it needs more study and improvements, we do evaluation. We do iteration to achieve further improvements. And then briefly talk about research more in detail. A system model has been developed for both tractor and planter circuit. Supplies from engine, it includes hydraulic variable displacement pump. It involves tractor electronic hydraulic remote control valves, connected to the four main functions in the planter: bulk fan, fertilizer, vacuum, alternator. This is just an overview to give a brief flavor and peek of the modeling approach. I'm going to use a low sensing pump as an example. What we're looking at is three different control valves: pressure compositor, flow compositor, and also the control piston in such hydraulic pump. Using a pressure compositor and zoom it out, the modeling approach is a lumped parameter approach. All the icons of their governing equations are labeled here. I'd like to note that this approach is taken over for all the system modeling, and it has been implemented in the commercial software Siemens Amazon. Since the pump is a core and the heart of hydraulic system. The correct modeling of this is very important to capture the right performance of the system overall. I'd like to show a dynamic validation results of this pump model. What we're looking at is a flow compositor stroking dynamic test, and the comparison here is comparing experiments and simulation. The idea is that load pressure, standby pressure, and also dynamically recover time, they all have a very high percentage of agreement between simulation and experiments, which gives us more confidence to use this pump to perform a system-level simulation. Talking about system-level simulation, I'd like to show another comparison between modeling and experiments to show the confidence and trustworthiness of the model that has been developed. What we're looking at is a comparison for 4 main information points for both pressure and flow rates of pump delivery and the functions. This is only one single remote test results comparison. However, there are in total 272 different remote tests considering different oil temperature, different engine speed, different flow commands, and in combination, average agreement is over 88% under all different conditions, which makes the model very trustworthy and satisfactory to be carried with to propose new solutions. Talking about solutions, there are 7 different solutions in total that has been proposed, targeting tractor, tractor planter, and electrification. Due to time constraints, I'm only going to give a brief flavor of the 3 solutions that's labeled here. Start with the tractor solution. This solution is called variable pump margin VPM solution. This solution, if we explain it using a power plot on the right, pressure being x-axis and flow rate being y-axis, the idea is we want to lower the pump margin with the help of another solenoid control valve. And then we can see the shaded area will be the power saved with VPM. However, the difficulty and the challenge here is how do we determine what pressure to be lowered at different operating conditions? That means different flow rate condition, different loading conditions. The VPM has been implemented in the reference tractor, and overall we're achieving percentage of power saving on average 6.7. Moving on, looking at the tractor planter solution, using a simplified circuit of tractor with planter coupled together, there are 2 different remote valves controlling 4 different functions. The IPSC solved the tractor planter hydraulic conflicting valve control inefficiency issue by intelligently control the supply pressure levels. The idea is that because of this control conflict, maybe not a lot of people know that the pump is actually always pump saturation when they're together. That meaning all the shaded area is a power loss that we do not need to face. The idea of this solution IPSC is we're going to lower the pump supply power. Then we can see the back shaded area will be the power saved with the solution. Again, the question is, where do we lower the pump delivery pressure to under different operating conditions? The novelty and the contribution of this work is that a mapping lookup map has been generated under different system flow requests and different loading conditions for the system to read and then control the electronic load sensing pump accordingly, just to have the optimized control for different conditions. And further, 12 in-lab stationary tests together with 55 field tests at Purdue Farm has yielded that IPSC can save 33.7% in mechanical power consumption and achieve fuel rate reduction up to 6.5% under different conditions. And finally, before I conclude, I'd like to briefly give a flavor of the electrification solution that's proposed in this PhD work. The idea is that we're still going to use a generator and then connect it to rectifier and to converter. The final decision shown in this plot is that using a pure mathematical and analytical approach, we decided that alternator, vacuum, down pressure cylinder are the 3 choices to be electrified, while keeping the fertilizer and bulk fuel fans still the same way hydraulically supplied as previously. This layout architecture can achieve 69% mechanical power reduction on the engine shaft. Well, finally, with that, I'd like to wrap up my presentation by highlighting that this research has achieved 2 Best Paper Awards, one being a SABE 2022 Superior Paper Award, and the other one being Global Fluid Power Society 2022 Best Paper Award, 3 journal publications, 5 conference proceedings, and 4 granted US patents, with 1 more to come. And with that, I'd like to thank you all for your attention and welcome any questions.
Thank you very much, and also congratulate to you for this very nice work you have done and for the very clear presentation. I'm really sorry for pushing you, but really the time is very strictly. So I know that kindly you are here, so I think that all the questions, and will be probably several, can be done to you during lunch break.
Let's do that.
So thanks. We can move. Thanks again, and applause again to you for your excellent work. And we can move to the third winner, that is Dr. Xun. Where is gone? Here is coming. And now we move to plant protection systems. Pesticide saving is an important topic. This one should be. Is correct?
Yeah.
Good luck.
Dear all the experts and colleagues, I'm Nu Xun, so happy and honorable to invited to attend this conference. And I born and live in a small village in the middle of China, and I obtained my master's degree in South China Agricultural University. Then luckily I got the financial support to pursue my PhD degree in Polytechnic University of Catalonia, and Professor Minhill is my supervisor, one of the best one in the world. And now I back to China to try to find positions in universities. And fruits is a very important economic crops, both in China and Spain. China's fruit production ranked first in the world. To confirm the quality and the yield of fruits, pesticides application are efficiency. However, only part of the input pesticides deployed on the intended target. For the worst cases, the off-target losses can reach 70%. This means because the difficulties for achieving a good application in orchards. One step is that there are large variations in canopy structure and volume. The other side, a lot of different sprayers can be used. It's not easy to choose a suitable sprayers with good adjustment. The good thing is that many measures can be done to improve the application, to improve the conventional application. In that case, the plant area was used to adjust the parameters. This figure shows the situation in Spain. A lot of target losses, a lot of risk of pesticides. This situation also happened in China, and it was generally recognized the working parameters should match the target canopy. And normally there are 2 applications. The optimized application, it means the parameters should adapt to the overall orchard characteristics. It can match the canopy at different growth stages. But when we check the canopy in the same orchard, there's also large variations in the same orchard. To adapt these variations, the new technologies should be introduced to achieve variable rate application with precise application. In this context, the canopy adapt applications can be introduced in orchards. The next issue is that to quantify the potential improvements of these technologies specific to the crops and sprays. And in this context, we should to know to what extent the pesticides can be saved to maintain effective biological efficacy. Because the limit time, I just show the drift potential of the caliper-adapted applications. Firstly, we developed variable rate sprayers in our laptop based on the feed tower sprayer. The up figure shows the main principle. The caliper was divided into 3 sections. Accordingly, the electronic sensor was used to characterize the caliper volume, and the trigger volume was used to determine the intended flow rate of each spring unit. And for the flow control, it was achieved by the proportional valve by changing the working pressure. And for the trails, this precise application was compared with a conventional one with a handy tower sprayer and optimized application with feed axial fan sprayers. And the trials was conducted in an apple orchard at different growth stages. The main difference is caliper densities. For the parameters, for the conventional one, the parameters are just following the practice normally used by the farmers. For the other caliper application, the spray volume adjusted was implemented with a 12% reduction for the optimized applications and 43% reduction for the precise application. Also, the air induction nozzle were used to mitigate the spray drift. And the whole drift trails were implemented following the ISO 22866 to quantify the ground drift and the airborne drift. For the results parts, and as expected, for the conventional and optimized treatments, the output volume rate was always constant. And in contrast, the optimized treatment, the output volume rate can be changed in real time to adapt to the caliper variation along the tree row. This demonstrates the effectiveness of the developed smart sprayer. And for the ground drift profiles, and the precise treatment showed good reduction at each sampling distance. However, for the optimized treatment, it failed to mitigate the drift deposition when the sampling distance close to the treated area. It may attribute to the difference of the sprayer type, because the conventional X-fan was used for the optimized application. Normally, this type of sprayer has a poor targetability with high risk of drift. And for the airborne drift distribution, the 2 caliper-adapted applications achieved drift reduction at almost all the sampling heights. However, the optimized treatment showed a much better drift reduction than the precise one. It may not reasonable, but when we check the weather condition, it may make sense. For the conditional of the precise application, the wind speed is much higher, and also the wind direction was more close to perpendicular to the tree row. It means it has a high risk of drift. And it's also great difficulties to fully follow the ISO 22866 to quantify the drift. And for the elbow drift at stage 99, the precise treatment achieved a better drift reduction than the optimized one, especially at the sampling distance at 5 meters. This means the precise treatment had a great advantages for the caliper with lower vegetation. And for the concurring part, the spray drift, the spray volume adjustment based on tree row volume can be an effective way to reduce spray volume. Also, the precise treatment had advantages to reduce spray volume. And there are great difficulties to fully following the ISO to quantify the spray drift. So it may be a good idea to combine the other alternative method to quantify the drift, such as the test bench and the wind tunnels. And the Calibrate adapt applications can significantly reduce the drift, both the ground drift and the airborne drift. So these applications can be promoted towards a sustainable use of plant production products. Also, the sprayers has a big influence on the drift deposition. So when we implemented the sprayer adjustment, the sprayer type should be highly considerate to achieve a high spray application efficiency. That's all. Thank you for your attention.
Thank you very much also to you. I think also knowing that in this room there are some colleagues really interested in pesticide application techniques, you will have some questions during the lunch break, so thanks again. And now I will ask please to the person that represent the two main entity that have been able to promote from already some years ago. As I repeat, this is the 5 editions of the Pellizzi Prize, that is the president of Federal Nacoma, but also the past president of Georgophyli, Professor Pellizzi, Picarolo, to be here. And now what I have to say to you is, again, so who is the winner? Because this is, or which are the winners? So as was mentioned by Professor Reinius, the score, the final score was really very narrow for all the 3 finalists. So for the management committee, it was not easy to really define the first one, but then we get this final value. Ready? And the winner is... we cannot see the screen. Why? We have to see the screen. Who is the winner? Dr. Sloan. Second one, Dr. Se. Third one, Dr. Tian. So, as I mentioned, so this winner of the Pellizzi Prize will be, thanks to Federal Nacoma, invited to follow the Club of Bologna for the next 5 years. This means up to November 2029. But also they will receive now an official pergamena, but also an official kind of recognition, money recognition that recognize their activity. So we go now to the ceremony. Thanks. Please. First one.
Thanks, Mr. Balzari, for your work, and but we hope that you still are here with this big team and high level that all the world look at this as a very important, and it's basically for the future of agriculture that we have your support, your work. We hope in the future to open and to promote this. I have already spoken with my people that we need you, and we need to transfer this on the land and on the companies. Thanks a lot, Professor Balzari. Really, thanks.
Thank you very much. Thank you very much. For sure, we'll continue.
Yes, yes.
And we will try to do our best, considering all the effort, not only financial, but in support that Federal make for the club. Thank you very much.
Thanks. Now there is a special something special for Marco Pezzini. Marco, Yes, it's a surprise. And I'm quite crying as the professor before, because Marco has been very, very important because he has put in connection you, that you are the... I'm a really bit emotional because it seems like to be young, no? When you enter in the class, there are, and here we are a lot of teachers, so... Anyway, Marco, thanks for the work that you have made with the Club of Bologna, that you have always believed of this work. I think that we have really to put more efforts in this together. Thanks still, but we will. You will have still important things to do in agriculture. Thanks. Thanks.
Thanks, Mr. President. Thanks to you all. Thanks to the president that I had during these years. Thanks to Piero, Pietro, because it has been a pleasure to be with you. I think that maybe in the future there might be some surprise. Maybe. Let's see. But it was really, really interesting. And my role has been to try to get the industry closer to the academic world. This was what I tried to do. And I think that in these years, we succeed in this. Now there's a new phase, and my successor will be challenged in this aspect. And the phase will be to bring the results of Club Bologna closer to the company, because there's a huge amount of knowledge, ideas, project. Only this morning we had fantastic presentations. So thank you for all this. Thanks.
Thanks.
Now we have, no, perché deve essere, sì, deve essere, però allora sì, la presidente della dire, lo faccio io, bisogna dargli, se te devi scappare, sì, questa, te devi scappare adesso.
Quanto tempo vuoi?
Non lo so, ma quando lo fai? Prima di mangiare o dopo mangiare? Prima di mangiare. Ah, ora.
Quanto tempo avete?
Abbiamo un quarto d'ora.
Ma allora, sì. No, questo è solo il regalino per il nuovo.
So thank you. Thank you again to Federico Coma, to Accademia dei Georgofili for this nice ceremony. And thanks also for all the winners. Also from my point of view, it was very nice to see people that was surprised about the final results. And this is another good thing. So you really see, understand how these young people really consider the importance to be evaluated from such a high-level person, professional person. And now we move, try to go a little up with the final part of the agenda, that it will take not so much time, but you have already understand that something will be changed in the club, in management for the following years. I will announce this in a few minutes, but before following the agenda, I just give the floor for the chairman of the study groups. You know, we have established 4 study groups, just with intentions inside of the club to analyze some specific topic. and tried to go out with some Club of Bologna guidelines, indications, suggestions, and some of this study group are already very close to the end because they really made a very good work. So I leave the floor. First of all, I would like to thank all the study group coordinator and chairman for the incredible work they have already done. And I leave the floor, and I started with Professor Peter Pickel, that is in charge of the study working group. Please, Peter, I don't know what is your presentation.
Marco?
Presentation.
Yeah. So, thank you, Paolo, for the introduction. So, as I'm guiding the study group ethics, it's study group 3, and I want to give you some review on a topic that touches ethical aspects, research security. Before I do this, I want to give a short review and another statement from our friend Giuseppe Gavioli. But let's start with the review. In 2018, we adapted a quotation from Max Eid to a principle of ethics. And the adaptation was, any technology is and must stay an instrument of human spirit, which itself must not be overruled by the spirit of the instrument. So we have to keep the control about new technologies, and this led us in 2023 to a discussion about the EU data strategy, especially on AI and the EU AI Act. And yeah, we formulated that principally AI is a statistical tool, and it can be assessed scientifically. This changed a little bit with the upcoming generative AI, which cannot be assessed scientifically, and it has, as you remember, it sometimes formulates simply wrong statements, so it's not controllable. And the conclusion was that generative AI has reached a new level of technology, and we formulated that the EU's data strategy, the AI Act especially, needs to be updated. This hardly has taken place, and we do not have any experience with this legal framework for artificial intelligence, as the AI Act entered into force just in August this year. So we have to wait a little bit until we see what the AI Act and this data strategy of the EU will reach. I fear a little bit that this is just a tool of bureaucracy, and thus limiting or hindering the force of innovation. One quotation that came up from our friend Giuseppe Gavioli, he said in an email to me, "Furthermore, I believe that analyzing the need for farms and agricultural machinery companies to consider and incorporate the value of natural resources in their economics could lead to significant benefits both for the companies and the environment." One of the ESG principles is recognizing that natural resources such as water, soil, air, biodiversity have relevant economic value, often ignored in economics and investment. This is so important, he said or wrote, that it should become an ethical principle, not just a recommendation for better economic evaluations. We need a general and ethical approach to sustainability, not just a practical one. And I would say this is completely true. Two comments from my side. The first comment is we should refer to the sustainable development goals of the United Nations, and we should also make it a little bit more precise that not only sustainability is a goal, but we have to adapt also our technologies to the climate change, because I believe that the climate change will take place, even if we would be able to stop CO2 emissions and whatever just today. This is not possible for several reasons. You can look at this diagram, CO2 emissions over the last decades in different regions. You see we have some improvements in the USA, we have improvements in EU 27, but if you look to the overall line, to the summed up line, which is the black line, the CO2 emissions will go up. And the reason is especially, if you look to the orange line, it's especially China and also India, which is the magenta line on the floor. And as I said, even if you would stop CO2 emissions today, the gas is in the atmosphere, and we will need about 50 to 100 years to get rid of it. So we have to adapt our technologies and agriculture with these to the climate change which takes place. Yeah, with this I come to research security, and this is in addition to session number 1. Research security is a debate which came up has come up over the last couple of 2, 3, 4 years with regard especially to public research. And the background is we are facing the return of military aggression as a tool of policy. I want to point at the war between Russia and Ukraine, the war in the Middle East. We see also that state-organized crimes, cybercrime is a new political tool, and we have an upcoming widespread ignorance of good governance. You can see it almost in all parts of the world, even in Europe and even in the US. And we see also that trade tensions are there and are increasing, likely increasing in the next couple of years. You know the reasons. So this limits a little bit, or the question is, does this limit the openness of research? And the discussion is overall in the world. Here's a quotation from the National Science Foundation in the USA, which says, research security is a critical matter. It is important that the research community, government agency, and our international partners have frequent dialogue to share perspectives and help shape our research security policies and programs. And further on, they say safeguarding US research security is paramount as some foreign entities continue to attempt to exploit American innovation unethically or even unlawfully. And similar observation you can make in Canada. So the government of Canada formulated Canada's research ecosystem needs to be as open as possible and as safeguarded as necessary, so it benefits Canada, Canadians, and the global good. And they formulate principles: academic freedom, institutional autonomy, freedom of expression, etc. Integrity and collaboration should be able, but should also be safeguarded. In the EU, there's a discussion here. I have a quotation from Orgalim. With different intentions. Research security refers to the safeguarding of scientific activities against misuse and undue influence by third countries or non-state actors. I don't want to read all of these quotations. You can do it at home when the presentation is uploaded. But I want to point out the ethical aspects that we have to discuss when we speak about research and open research and corporations, what we discussed in session 1. So an ethical aspect is, on the one hand, that we have to protect our scientific integrity, but we have to guarantee that research, and this is an ethical principle, has to be made for peaceful and sustainable purposes. This is what I think everybody here in the room aims at. Open science stands against security concerns. Equal opportunity and accessibility to scientific research must be given. Surveillance stands also against privacy, and researchers have to take responsibility for technological innovation. So the conclusions in my short presentation is the global debates, and they are even going on in Russia and China about research security, reflect similar concerns. We have to protect sensitive technologies. We have to safeguard against foreign influence, and we have, on the other side, to ensure that research institutions are secure from cyber attacks, and maintaining ethical guidelines in research is extremely important. So what to do? The questions that we have to discuss is how can we protect IP in the future? Even patents will not be helpful to protect our IP. So will we go into trade secrets that hinders the global development, or will we go for patents, or will we develop different methods? Can we stick to open science? And finally, how should research funding address research security? Things to have to be discussed. So I'm not raising so many answers, I'm just raising some questions. Thank you for your attention.
Thank you very much, Peter, for always, as always, really underline the important topics still to be analyzed. So we have not so much time, also because our president of Federal Coma, has to leave. Joseph, if you have just want to say something about your study group, or yes, if it's a short one, because Danilo can escape it. Yes. Is about dissemination, and Emmanuel also, because has left, so we can have just your short presentations, and then we move to the.
I think from the initial activity of the study group, we were focusing on Africa, mechanization in Africa, trying to see what is happening in terms of mechanization there. How can industry and governments, how can they work together to get there? So, and one partner in this work is of course the FAO. I think somehow, I think it was also Josef's work and contribution that helped to waken up FAO to the fact that mechanization is probably the future for food security also in Africa. So in 23 we had this global conference on sustainable agriculture mechanization, which really drew the attention to FAO and to mechanization. With, I think there's more than 8,000 people that subscribed to that meeting, and so it was followed very broadly. I think you can find the results or the conclusions of that and many of the aspects that were treated there in this booklet. Joseph has it, but it will also be in these proceedings that you can also download from the internet later on. I think as a result of that, one looked at where is industry, how can we involve industry also in this type of activity. And so there was a meeting with FAO and CIMA and the people, I think they represent also the Italian industry. I think they try to position the Global Agriculture Mechanization Conference and the challenges for mechanization that will arise for the companies in Europe. I think we also asked CIMA to make a survey of the activities of its members in Africa. We have some idea about that. I think the General Secretary was going to give a presentation here about it, but I think that may come later. So there is some awareness that we now have about the company activities that should come to Africa. So the African Conservation Tillage Network is a very active thing that we could get involved in. There is also an investment center that is doing some collaboration for on the west coast of Africa, and I think also there was an activity where they were invited to China to look at cooperation there on mechanization. I think the other one is that there is a global innovation challenge of FAO through Farmer Field School to come to mechanization for small-scale producers. How can they be as innovative as possible just to make sure that it happens? So it's a competition between countries, and I think in this coming week they will be in Rome to come up with the best ideas to that. There is also some activity on post-harvesting. I think also we have discussed the ways of entrepreneurs, how can they get involved, how can they stimulate mechanization there. There is some forms of some different ways of doing that, of having entrepreneurs. I think we can have some discussion on that also. And I just want to have also this one little thing. We've seen here that there was an electric tractor that got an award here on in the exhibition. There's also the consideration that there is so many thousands of two-wheel tractors out in the field. Maybe there is fuel for them available using electric tractors. So one of our colleagues is doing work in the Pacific region, but I think it applies to all of Africa as well. The second consideration is the status of women in agri-food systems, which is another thing that I think has to be considered for the whole of Africa. Everybody is involved in that. And I think the state of food and agriculture and the automation. So these are three aspects that one has to consider when we think about Africa. Here it is in the Pacific region, but I think it's all of us are involved there, and it's also for Africa. So I would like to stop it here and say, think about it, because we can draw some lessons, and we could have the consideration of women, automation, and electricity empowering agriculture in Africa. Thank you.
Thank you, Joseph. Thank you very much for the work done and still going forward in these important topics about the study group you are chairing in such a good way. So now we go to the closing, and where I try first of all to summarize what has been the decision taken during the last management committee meeting. And you know that inside of a club we have internal rules, and during a meeting we have online in 2021, we have agree inside of a management committee that the present president and management committee members end their mandate this November. So this means is the last Club of Bologna meeting managed by the present management system. And following again our internal rules of the club, Federacom have identified the new president, that is Danilo Monarca. Danilo.
For the club of meeting. So thanks. I have known the Professor Monarca in a very nice event that has been G7. We know each other in a special panel for the young people in agriculture. So I have a nice remember of you. But good luck.
Thank you,
That's all. But really, it's impossible Professor Monarca, it's impossible not to do a nice work with all these people, eh?
Yes, for me, it's an honor that Federacom has made to repose on me their fate. And so I think that my way is not so difficult, because I have only to follow the line that Paolo and the other president has described in all this year. I think that in the next 3 years, we, with other manager committee member that is renewed dramatically, we can do really a good job with the help of you. I'll call you, I'll telephone you, I make with you Google meetings, because I want the support of everyone. Thank you very much.
Thank you, Danilo. I'm sure you will go forward better than me and in a very good way. But we take also other decisions, as was mentioned. Not only the Club of Bologna Management Committee have decided, thanks to Federico Nacoma, to have the new president, but together with the incoming president was also decided to establish a new management committee. Maybe here the name doesn't say to you so much, but just to give you an information that will be the 10, no, because I think that it's better to see the picture here. So this is the picture of the new component of the new management committee. So congratulations to everybody. The main spirit of the present management committee was try to have from one side persons that have already experience on this, despite the past president that for the internal rules will be present, but also Peter Pickel that have a very good activity, and he make really a lot of effort during this year. So, but also a lot of young people that, or other people like Professor Schulze-Lammer, that is a full member from a long time, but never been before in the management committee, but he know everything, how the club is working with very new people, young people like Dana, that was a Pelizzi Prize winner. I want to mention this to the president Maschio, because Dana, just to have information, Dana was a Pelizzi Prize winners, but now is a member of a management committee. So we decide to have young people inside because she has always been very, very active. And also, last but not least, if you look at the figure, she will be the only woman inside of a management committee. And so we started to have a woman inside of a management committee, and this is another very important aspect we try to follow. So again, see, the suggestion was, but before make a picture, I want also to underline, you have understand, and was already mentioned by Marco, and I'm really thanks him, but I will do also later on, about his activity, but he now will not follow again the management committee, but we have Fabio Ricci that take his place. So Fabio, I know Fabio from probably 30 years, so I'm sure he can do another very, very good work as was done by Marco. So Fabio, really welcome to a member. So. And now, this is a good idea. If all the members of the management committee can be there for a picture all together, the present, yes, the new one. Okay, all together, present and past. Okay. Sorry, sorry, dear friends, we have not really finished. I have some additional communication to give to you. Also important because are also related to the next meeting, place and the time. So please remain another, no more than 5 minutes. I promise you no more than 5 minutes, then we can have a lunch break. But please stay here. So, as an important information, the next meeting will be in October 2025. Please, 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 in Agrilevante, in Bari. So this is a novelty. You know that normally we have 1 year in EMA, 1 year in Agritechnica. This time Federunacoma also to promote this new fair that is organized by Federunacoma and also try to have a club Bologna in an area south of Europe where they wanted to promote a specific mechanizations. They asked to have the club of Bologna there. So this is what has been decided and this is what will happen. As we normally do during the last Management Committee meeting of the, I can say now, all the Management Committee meeting, we have also discussed about possible subject for the next Club of Bologna full member meeting. So we have defined 2 topics. First one is the tractor in the future, market and technical trends. It's still a very draft title. We have asked the man that have spent his life in tractor research, that is Professor Reynus, if he can coordinate this section. You say maybe yes, maybe not. So this is the reason for which there is the question mark. But maybe yes, maybe not, just because he say I'm not sure to be next year so with a good health as I am today. So he say leave a question mark. Session 2 is still to be defined. We have some proposal, but I'm sure, as was mentioned, that Danilo will come soon to you, to the new Management Committee, to define the new topics. Section 3 is related, as usual, to specialized mechanizations. In this way, as I mentioned before, we try to involve the country from Africa that are, I mean, from South Europe, very South Europe. So we call it here Machinery for Emerging Countries, but is also a very draft title. And who better than Joseph, that is the chairman of the study group, can coordinate and chair this section. So Joseph kindly say yes, he will be able, but again, this is just a very first approach. So then Danilo will go ahead. Then we decide also, and this was something that was really requested by Federunacoma, to start with a new study group about how we can improve the relationship between university, public research center, and agricultural machinery industry. And again, we ask to a person that have already a lot of experience about this, not only in the United States or in Italy, but all around the world, and he kindly say yes, and I have thanks him, is Giuseppe Gavioli, that as you see is also a member of the new Management Committee. So many thanks, Giuseppe, for manage this. So final remarks. As usual, Marco will upload all the presentation on the Club of Bologna website. Please remember to fill the session case sentence form that can be also downloaded from the Club of Bologna website. But now this is really the last slide, probably also my last slide in the club. Before officially close and leave my presidents, I really would like to make some thanks to somebody. First of all, the still up to 5 minutes ago, Management Committee members, for very great support, suggestion, disponibility, and a special thanks to Professor Gasparetto and Bodri that introduced me already several years ago in the Management Committee in order then to allow me to become a president. So really many thanks, and also many thanks to other two persons I wanted to mention because, or three persons, but one still remain in the Management Committee, that is Peter, but the other two are really two persons that helped me a lot during this year, that is Professor Renius and Professor Munich. So really many thanks for your support during this year. Then I wanted to really thank Federico Nacoma, starting from the three presidents that I have met during my period, Goldoni, Malavolti, and Maschio, the director, and especially Marco and Patrizia. So I'm sorry that Patrizia has left, but these two persons, or without these two persons, was not possible to have done all the activity we have done, and I was able, and I have also the honor to do during these 8 years. I would like also to thank all the keynote speakers, chairman, rapporteurs. We established during my presidency this figure of rapporteurs that work very well, and I really have to thank all the rapporteurs, especially the study group coordinators. We just have the presentation of two of them, but all have made a really great job, and especially also the rapporteur and keynote speaker of this meeting. And we arrive to the key point. Key point is Marco. Marco really I would like to just to underline one of the words I wrote here, despite help and friendliness, patience. Because I know that it's not easy with me, but he demonstrated a very big patience and disponibility. So really many, many thanks. Without him, it was really difficult. So thanks. So goodbye to everybody. Have a safe travel back home, and now it's time for lunch.